Hello, good morning, happy day. Now, we'll shut the door soon and lock it. So we have a few local messages in the beginning. So, Wesley.
Good morning. Hi, yes, I'm back. I have to, there's just a few messages for today. One is please remember to actually leave lunch. The hotel wants you to leave the lunch after an hour and because they have to set up for another group. So at, what is it, 2:30? No.
12:30 to 13:30.
1:30, please leave the area downstairs. And the other one is that when you leave, if you don't want your lanyards, we will take them because we want to reuse them and wash them. So if you want them and bring them home, that's fine. Otherwise, just leave them on the tables or out with us. Yes, thank you. Enjoy.
The stage is yours, Ute.
Good morning, everyone. I hope you're awake and ready. We have a very exciting session today. We have 20 presentations and 36 posters today, and we will be our chairs. So let me introduce my co-chair, Christine Kouatanouan. Did I say that wrong? And she's a researcher and data science management from Ifremer in Brest. She's with a PhD in oceanography and very focused on automatic data quality control. And she focuses on physical parameters within the Coriolis data center. Very impressive. Christine has been involved in several international and European projects such as Sea Data Net, Sea Data Cloud, and now Blue Cloud 2026. And I heard there will be 3 posters around that, or a lot of them. So go and have a look. And she's fully involved in the Argo program for real-time quality control and delayed mode data.
Okay, thank you, Ute. So let me introduce now Ute Brunner. Ute Brunner is a researcher at the Norwegian Research Institute SINTEF Ocean in Trondheim. With a background in mathematics and computer science, she focused on ocean observations and ecosystems within the Climate and Environment Department. Since 2010, Ute has been involved in environmental risk assessment for marine industries. She is passionate about integrating available data with both existing and new software to support decision-making and promote sustainable ocean use. Ute is also responsible for demonstrating pilot application in the digital twins of the ocean project Iliad, an European-funded initiative aimed at creating interoperable digital twins from existing ocean observatories and applications through an integrated digital framework for comprehensive maritime data and information services. So very impressive about that.
Thank you, Christine. And then you will know that the keynote is very close to my heart, and it is Owen O'Grady on Ireland's digital twin ocean. Digital ocean, sorry. Oh, sorry. still very close to my heart. So welcome. You have 20 minutes, 5 minutes for questions, and the floor is yours.
All the organisers for a fantastic event, really, really good. It's great to be back in person at IMDIS, and my name is Owen O'Grady from the Irish Marine Institute, and I will present on some of the work that we're doing over the past several years on the Digital Ocean Programme, and more particularly how that supports the work in developing digital twins. And digital twins will be very important for sustainable development of our marine sector. So to start with, we all know there is a growing level of activity in our marine spaces. In Ireland, we have a huge push towards offshore renewable energies. There's also significant change in our climate and a need for enhanced access to information across many marine sectors. Relevant and timely information is going to be critical for sustainable management, development and adaptation, and in particular to help our stakeholders, policymakers and the general public to understand what is happening and to make good decisions that affect our marine. And digital capabilities are going to be key to this, especially tools such as digital twins can really help communicate and present our information and outputs to these key stakeholders. If there could be two different taglines for this one presentation, they would be repurposing the wheel, not reinventing. And thank you, Tara, for that one. And also bringing it all together. So repurposing the wheel is really about building on the foundations that we already have in place. There's been a huge amount of work over the past 10 to 20 years in data integration and interoperability, not least by CDataNet, Eurogoose and many others. So we're building on very solid foundations. But bringing it together can sometimes be the harder part, and that really is where the challenge is. And there are two very important programs at the moment that are bringing it together, the two decades, the UN Decade of Ocean Science, the science we need for the oceans we want, and the European Union's Digital Decade. And these two decades are bringing together activities which will help with our digital transformation. The implementing actions will help to transform not only how we do marine science, but importantly, how we communicate it to key stakeholders and how we present that information in a usable way. Our digital journey will enable the science we need for the oceans we want. And in the Marine Institute, we are working across many of these areas, leading a transition in national digital services to support sustainable oceans development. So we're taking a very strategic approach in the Marine Institute, and particularly with our Digital Ocean Programme. While evolving digital services will include developing digital twin capabilities, they will be developed on existing services and capabilities such as integrated data services with quality management. And quality management is going to be absolutely critical. Can we trust the information that we're presenting? Analytical tools and capabilities are developing at a rapid pace. We see many posters showcasing the new capabilities, cloud services, etc., artificial intelligence, new visualization capabilities. So how can we adopt these and make them integrated into our systems and services? And then looking at targeted service delivery for specific use cases, and this is really critical. How do we deliver specific services that matter, that are relevant, that are usable by key stakeholders? Our strategic vision is that digital twins of the ocean will make marine knowledge readily available to policymakers, businesses, scientists and citizens. And more broadly, that our digital transition will transform how we operate, how we engage with our stakeholders, and how we deliver our services across a wide range of marine sectors, ocean renewable energy, marine transport, climate adaptation, etc. So, like I say, we are building on capabilities that have been developed over many years. So we started our Digital Ocean Programme roughly 7-8 years ago, and it was with an aim to integrate very diverse data sources and add value to the work that we do. And this is echoed at a European level, but it's very important nationally to do this. We have made very significant progress over the past 8 years. We've integrated quite a number of data partners, into a digital ecosystem. We've applied trusted quality assurance to many of these data processes, and we're adding analytical capabilities on top. And this is really important because this is where we can suddenly add a lot of value for a lot of different use cases. So we're looking at the areas of smart ports, for example, climate adaptation, marine spatial planning, fisheries management, and so on. And it's at this level that we can suddenly add our expertise, our knowledge, to provide the services that can inform policymakers. So you might be more familiar with this particular diagram where we are connecting in situ observations from many different sources, be it fixed platforms or mobile, from ships, gliders, autonomous devices, etc. We're adding in modeling capabilities, so allowing us to predict ahead or to look at what happened previously. And we're adding in remote sensing capabilities, which is growing every year. So more and more data sources, more and more cross-disciplinary I suppose feeds that we can connect in and add to our decision support. And that's really important. We can make these available in an easier to use manner by expert users, scientists, domain experts, and so on. And then adding our digital capabilities to deliver this information and data to our key stakeholders across many different marine areas. And this is where digital twins in particular will help. It will connect data, expert input, digital delivery of our information, and will connect it and make it usable for those stakeholders. So I suppose that is probably the key for our push towards developing digital twin capabilities. A key challenge for us traditionally has been to bridge the science user divide, to move outside of our traditional client base, our user base, technical scientists, engineers, and so on, and make the information that we all know is really important available to a much broader set of users, be it the general public, be it policymakers, be it marine managers. So digital twins will help to bridge that user science gap. It will provide more interactive information in a visual way. It will present information in a real-world, understandable way to these users. And it will combine data from multiple sources and disciplines in a much more coherent and easy-to-use manner. And it supports scenario modeling, which I think is going to be increasingly important as we look ahead at what might happen, what will happen. So bringing it all together, the second tagline, this is possibly the key challenge. Traditionally, we've operated in disciplinary, I suppose, bubbles or communities, but more and more that we're integrating across communities. We're providing integrated data, integrated information, and integrated advice. And that needs to start with the end user. So bringing end users into the conversation early. We hear about co-creation regularly, and it is really important. The earlier we can talk to our end users, the better the results, the better the outcome. We all know we have a lot of marine science and marine domain expertise, but how do we convert that into usable information? So including the marine scientists, the domain experts early in the conversation, also really important. And this community in particular has been developing integrated, trusted data services, combining data from many, many different locations, disciplines, and so on, and platforms across Europe and wider afield, and making it available. So huge progress in that area over the past 10 years. But now we have an opportunity with the digital decade, the digital transformation that is happening right across our communities. How do we apply these new digital tools, capabilities, and services to our marine science information? And that's the challenge, bringing these four parts together to provide usable information that's relevant to our key stakeholders. And like I say, this is building on what we've done over many years, so it's not reinventing the wheel, it's repurposing. So here we have many existing services that we're providing from the Marine Institute nationally, looking at marine planning, seabed data, looking at more interactive observation through Ireland's digital ocean services, looking at the renewable energy space and providing information for that community. And increasingly we're adding smarts or intelligence into these services, looking at licensing decision support, for example, harmful algal bloom predictions, and looking at providing statistical information in more usable ways through digital stockbook, for example. So marine data is coming from many, many different sources, and you're all very familiar with this, but it is underpinning our digital transformation and our digital services, and every digital twin will need to build on these building blocks. In Ireland, we have 700 plus data sets integrated from more than 30 different national partners. Standards and interoperability, as you know, are absolutely key to this, and it's building on a lot of very, I suppose, well-embedded work from CDATNet, EMODNet, the work of BODC on the vocabularies, EMSO, ICES, and many, many others. And increasingly, we're seeing integrated access to data. So Conor was presenting on the EMODNet central portal, and this is really important. No longer do we have to go to multiple locations to get data. We can go to one location. So these new capabilities and this interoperability will support implementation of national programs such as marine spatial planning, DCF, MSFD, aquaculture development, and so on. And the second, I suppose, key point, and this is maybe again something that everybody is very familiar with, but is becoming increasingly important, building on data that you can trust. So if we are to provide policymakers with decision support systems, they need to be able to trust the information they're being provided with. So how do we provide that trust? Quality assurance is a key part of this, and that is going to become increasingly important. In the Marine Institute, we've applied the data management, quality management framework, which is based on the IOD quality management framework, to over 120 different processes. So we have process maps from where data was acquired through to when it's being used. And this provides the assurance that end users need. They want you to be very transparent. They want to be able to trust the data that you're providing. And building a trusted evidence base requires marine science expertise, marine domain expertise. So bringing together the data experts, the science experts, and the digital experts is going to be key. So looking at the data value map, and this is, I suppose, a standard way that we look at our processes. So we have two people, one on the left and one on the right. On the left, we have the person acquiring the data, and on the right we have the data user. And the closer you can get these two people, and the better they can communicate together or understand each other, the better the end result. So if the data creator understands why the data users will want their data, they'll understand how to acquire it better, how to process it better, and so on. And if the data user understands where the data came from and how it was processed, they'll trust it. And they can use it for decision support. They'll have much more responsive and efficient access to information. So an example of where we've applied this is for marine spatial planning in Ireland, developing the National Marine Planning Framework with the Department of Housing Planning and Local Government. Data from more than 30 different partners and sources was integrated, quality assured, and made available. This was integrated into the first Marine Spatial Plan for Ireland, the National Marine Planning Framework, and was published digitally. So it's available online digitally through Ireland's Marine Atlas and through marineplan.ie. It's an accessible and authoritative source of marine data for Ireland. And this is important because while we're looking at repurposing and reusing, this evidence base can underpin many other uses in the future. So the second key pillar in our Digital Ocean program was enhanced visualization and analysis tools. We've developed a toolbox effectively of these tools which can be applied to various different user needs and services. Real-time MetOcean is integrated, interactive seabed viewers, numerical models can be presented online, streaming data can be interpreted, automated analysis and processing services, and interactive augmented reality. So this makes data much more real to the end user. It shows data in ways that users expect to see it. People using Google Earth every day or Google Maps will want to see interactive 3D visualizations. And here we see data from the Infomar Seabed Survey in Galway Bay using WebGL, Also on the bottom, we have a shipwreck again from Infomar, which is using SketchUp and based on the same data set. Top right, we have model data again for Galway Bay, and they're all in the same area. Bottom right, we have augmented reality, and this is very impactful for communications and outreach. So these tools can be adapted and reused, and while we're developing each of our new services, we can reach into our toolkit and make use of existing capabilities. Here we see the flow of water through the Aran Islands superimposed over Infomar very high resolution bathymetry. Here we see Argo floats in the Atlantic from Newfoundland across to the Porcupine Basin. And these data are integrated into one central portal. So a user doesn't have to know where to go, they can just go here. Like I say, this is a toolkit. It is adapted for different use cases like ocean renewable energy. The Ireland's ocean energy portal uses services from DigitalOcean and so on. And this is integrating data from many different sources. Here we see high resolution Infomar bathymetry. Here we see real-time tide gauge information from the Marine Institute. There's augmented information from OPW, from CIL, and from other sources also. And moving into the newer tool sets and the capabilities that are coming, we have new GIS spatial services which can be adapted and bring some of these capabilities, which in the past have been point solutions, to a more integrated set of services. And this is really important. So here we see the port in Galway, which is a relatively modest port, but it's a real-world view of that. There's also a digital view with sea surface temperature superimposed. And this allows us to start analyzing using spatial services, our oceanographic data, our habitat data, various ecosystem data sets, which can be combined together and presented online to key stakeholders. Here we see a new version or prototype of Ireland's Marine Atlas using the Teria map software. And again, it's developing a service which existed for several years using traditional GIS, but this is moving into 3D interactive online visualization. And it makes a difference because people can relate to what they're seeing. It also connects into many different data sources, and like I say, we don't need to connect to multiple eModNet catalogs anymore. One is sufficient. But these capabilities are allowing us to integrate our data, and this is really important. It's moving beyond simple visualization to GIS spatial analytics. So the Marine Atlas in particular is developing over the next 3 to 6 months, and it will be an important national reference service for marine information in Ireland. It will underpin a lot of the development work that we're doing at the moment, particularly around the offshore renewable energy space. We can integrate 3D data modeling and seabed capabilities, and it's going to evolve our digital twin capabilities. It'll be part of our toolkit that we can use elsewhere. So why add digital twin capabilities? Improved understanding and evidence-based decision-making. For example, for our aquaculture licensing decision support tool, the users want to do the spatial analysis, but in a user interface that can be shared across their department. They want to add real-world visualization, they want to add high-resolution bathymetry, and they want to add model data. So we can do this with our new toolkits. And there are many different use cases that we can apply this to. Marine planning and licensing, for example, marine transport and ports, many different studies looking at potential for digital twins, ocean renewable energy, fisheries and ecosystem, and so on. It's going to be extremely important for climate adaptation also. We have a program which looks at developing the services on an operational basis, so it's really important that we're building in that operational resilience, robustness. Cybersecurity is built in. We've a robust platform. We're integrating research activity and developing our digital skills. And applying this to marine programs, that's the key. This is where we connect with our end users. So we're working in many different programs in the Marine Institute, from ORE through to marine planning, fisheries management. We're looking at aquaculture licensing, particularly climate adaptation, maritime and ports, and food safety. So many different use cases that will be using and building on the same capabilities, but it does rely on us bringing the various parts together. And absolutely key that we get the end users talking early with the scientists and with the data experts, and that really is the key. It's bringing it all together and building on what we have. So to finish, repurposing the wheel, we're not reinventing, we're building on what we've already, the capabilities we've developed, and we're evolving these. But bringing it together is really important. The new digital twin capabilities are going to play a key part in the transformation of our services and how we deliver for national programs. We're building on trusted, integrated data. We're building on advanced visualizations and modeling, and existing data partnerships with user-focused services. We believe that digital twins of the ocean will help to make marine knowledge more readily available to non-technical users, and they are absolutely key for the sustainable development and management of our marine spaces. Thank you very much.
Thank you very much. Is this on? Yes. Thank you very much, Owen. Right on time. Of course, we take questions from the audience, as usual. Any questions? There you go. Yes.
Thank you for the wonderful presentation, really, and the work that is behind it. I was wondering, you are talking a lot about data integration. Is this integration done through the services, or are you also harmonizing the metadata, or are you working to harmonize the data to let's say, speed up this integration for your services?
I think it's not just one approach. It's a mix of approaches where we do harmonize some data for certain organizations. We integrate and federate, to use a word that's possibly overused, federate data from multiple partners using services like ERDAP and so on, GeoNetwork, etc. So there is a mix of federation, harmonization, and central hosting and services as well. So it's a mix, but it's using standards that have been developed by this community, and that's probably the key. Yeah.
Oh, brilliant presentation. I really like, especially the visionary part. What I want to ask you, let's say, I see you also, you went in the 3D visualization with the cesium, which is of course the new engine, let's say there's a new one. But are you also going into gamification, let's say using Unity and these kind of things? Is that something planned?
Yeah, absolutely. I was just chatting with Peter earlier. We've used Unity in the past for augmented visualization using Microsoft's HoloLens devices, and also for online interactive modeling data. But we did find that technically there's quite a high overhead with Unity, but maybe that has now changed. It's certainly something we'll re-look at, and certainly have a chat with yourself and Peter.
Because especially for decision processes, it's really people play the game as it was in the real world.
Yeah. I will say the augmented reality has a huge impact on for outreach and communications. Really impactful to be able to walk around a shipwreck, touch it, see it pop up, get information on what's happening. It's really powerful. Yeah.
Thank you. Thank you for a wonderful presentation. My question is on interoperability efforts with other digital twins nationally and then internationally. What is going on?
So yeah, nationally, Met-Éireann are leading the Destination Earth working group. So we're connected in with that working group, user working group. So there are regular discussions, and there was a really good workshop in November bringing together the various partners. So there are discussions on use cases, etc. nationally, and internationally we're connected into the Ditto program, and keeping an eye certainly on the Iliad program as well, which is making great strides in the area. So we're watching the space, but we're developing organically at the moment.
There is a new group in RDA for digital twins and for landscaping all the coordination efforts and the digital twins projects that are being developed in Europe and internationally. So it would be a pleasure to join the group. So if you go to the RDA page, of course you too, it would be great to have more people to connect in order to create interoperability.
Super, yeah, sounds great, thanks.
Yes, then I can just add that we also have this interoperability working group under Ditto, and we meet once a month to just chat about digital twin interoperability. But more questions. I think we have room for one more question. If not, then I can ask my question. So since you're catering to so many stakeholders and probably different user interfaces accordingly, what does that mean for your data management? Do you have different data management, or do you really have one underlying data platform that can cater to all of these?
Yeah, I think that's probably a key thing, to have one underlying platform with multiple interfaces, excuse me. So we have spatial interface, we have real-time interfaces and so on. But it is a singular set of services that are reused for different users and use cases. Absolutely, it would be very difficult to maintain it otherwise. Yeah.
That's right, but you don't need any conversion in between to cater to the different dashboards, Unity, whatever.
There may be some custom work, but in general, it's the same platform. Yeah.
Thank you very much.
Great. Thank you very much. Thank you.
So now let's move on to the next speaker, Joanna Beja. Okay, so we will speak about the BioCheck tool, a comprehensive approach to marine biodiversity data validation.
Is it services?
Yes, it's services, and then it's your name somewhere.
There, yes.
Right.
Yeah.
And it's a PDF.
It's
so,
a PDF.
But then you
So
probably have to
I'll
go
have
to.
do this, and I'll have to do. And I think I'll just have to show it, maybe.
F11 or something.
No,
No.
that's not it.
Tools. How do we get in full screen mode on a PDF? F11.
Yeah. On a PDF.
Not this one. No.
No.
Somebody help, please. Yeah, isn't it?
Control F?
Or F11.
No. Control F, it's Control Find. F11.
2 minutes.
No.
It's okay. It's full screen now, but it's not there.
It's not. No. Yeah.
I think it was out yesterday. No.
They said on the right side, so it
On
should
the
be
right
maybe
side,
one
yeah.
here.
It's not full screen.
Oh, there you
think
go.
it's that?
Okay, now we have it.
Ah, yeah, there you go. Okay. So good morning, everyone. So yesterday, my presentation was focusing on IMDIS biology as an initiative, and today I'm focusing on a tool that we've developed to quality control biodiversity data. I am presenting on behalf of Ruben because he couldn't be here. So I think all of you will know why we need quality control. I think preaching to the converted here. We all know it's an important step in the data life cycle, and that errors can come from different sources. So in the images we have, for example, a marine biodiversity monitoring program in Svalbard, but as you can see, there are some records in India, so what's going on there? Basically, the latitude and longitude were swapped. And on the right-hand side, you have also a monitoring program in Belgium, but with some records in the UK. And in this case, it was a negative longitude sign that was added. Yeah, so we have a lot of different things, which I'm sure many of you have encountered as well in the data that you work with. So in this slide, we have a drop in taxa records from 6K to 4K. And this is due to spelling variations and to synonyms in taxa. So when we're doing, before publishing data, so when we're doing quality control, there are a number of things that we have to look at. so that the data have the highest quality possible and they are useful and reusable for everyone. So the quality control is essential to accurately comprehend and forecast species populations, trends, and supporting well-informed decisions and conservation and ecological matters and policy. So the biocheck tool. This was developed as a collaboration between the LifeWatch and IMONET biology projects. As you know, IMONET is an EU service for marine biodiversity in situ data. And as I've said yesterday, one of our roles is also to gather and publish high-quality biodiversity data with its associated parameters, be it environmental or related to the taxa that was observed or collected. This tool works on IPT resources. So IPT is a tool that is used in the biodiversity community. It's a tool, it means integrated publishing tool. It's developed by GBIF, the Global Biodiversity Information Facility. And it's basically the tool to share biodiversity data. So the development of this tool is done by GBIF. Anyone can host an instance and just do the technical maintenance, meaning the upgrades. But if there is a bug, that will go to GBIF and they do that development. And it's used in GBIF, as I said. It's used by OBIS, the Ocean Biodiversity Information System. And of course, it's also used in IMONET biology. So the tool that we developed performs two main different actions. One of them is provides a data overview of the data set that you're quality controlling, where you can have an overview of the sampling events and the occurrence records. Occurrence records referring to the taxa itself. Any associated parameters that you might have, as you see there in green. Geographic coverage, so you can see immediately if something is off, like that record in the which is not in the Mediterranean, so there's something that could be wrong there. And temporal coverage, taxonomic coverage as well. And it also performs various quality checks. Actually, it's over 50 quality checks. And some of them are checking if the depth of the sample is deeper than the seafloor depth. If there are marine taxa reported on land, which is not always an issue, I have to say, for biodiversity. And I can explain why later. If you have invalid dates or coordinates, do note that in biodiversity we also work with historical data. So if you think that Aristotle is the father of biodiversity, so you can go really far back. And also, we can't forget indigenous communities recording data through oral history. So all of that information is important. So we go from before Christ all the way to the present. So it's quite a large temporal coverage. We look at impossible values. So if you have a zero weight in a taxa, why do you have it? Was it recorded? Was it not recorded? So things like that. And any vocabularies that have been deprecated, so we recommend using the ones that are in place. In terms of the scope, the tool was developed for marine data sets, but because it uses the IPT, it can work with terrestrial or freshwater biodiversity data. In terms of the data format, we adhere to Darwin Core because that's what the biodiversity community does use, and is very effective with the OBIS-ENV extension, which allows for the inclusion of those environmental or biotic or abiotic parameters. It currently is done as in R software. You can use it in either as an R package or as a web application. And for the usage input data, so your data set needs to be in an IPT resource. I will just go through very quickly on how it looks like with the web application. So you have, on the right-hand side, linked to where your data set is in IPT. You will have those two menus where you can see just the data overview like I explained initially, where you can see like a map with the locations and you can immediately see if there's anything that is off. And then you have the various quality checks that you will have to go through and resolve any issues that are found. On the About tab, and I think this is actually the last slide, there is a video showing how to use the tool step by step, and there are some references and other links that you can follow up to learn a bit more if you're not really knowledgeable about biodiversity data. I just wanted to finish and explain why marine taxa on land is not always an error, because we also work with museum collections, and museum collections from the past, they didn't necessarily record locations of where the samples or the creatures were collected. So in many cases, the location will be the museum where the collection is. So you can have some marine fish that were gathered, I don't know, in the Galapagos, but they will be somewhere in a museum in the UK, for example. So they're not necessarily all wrong, but you do need to look at them because, yeah, some can be wrong. So there is always it's not a blanket approach that you always need a human to understand the data that you're looking at. That's it.
So is there any questions?
Thank you so much.
Okay.
Any questions? Do you collect user feedback on this tool? So I guess it's online available now, so
well, not us because it's a GBIF tool.
Yeah.
But yeah, but we provide support to the data providers as we can. But as I said, if it's a bug in the tool, we can't do anything about it. So, but GBIF has a GitHub repo for that, so you just have to log in a bug and they'll sort it. Okay. Yeah.
Any other questions? This is important.
So it's a published once, and it will be available in different repositories because of this, without extra work.
Yeah.
Really. Yeah.
And how do you do that? You said you look for deprecated taxa. Is that manual work or is that regular updated in the tool?
So we have, with the worms, we have a taxon match. And as you're matching your species names to the IMDIS, like we call it, which is the identifier for the taxa, you can... For taxa, it's not necessarily a problem because things are very dynamic in biology. Something that is not real today might be, again, accepted tomorrow. But for example, with the BODC vocabularies, of course, the collections do change, and some terms are deprecated, replaced by others. And if we find any deprecated terms at the time of submission, we suggest that they are changed to the current terms. But the links will always be there because that's BODC is very good in keeping those. So it's, yeah.
Thank you so much. Okay. If there are no any further questions, we would move on to the next speaker, and now I have to look at my notes. And that is Peter Theisse from IMDIS, presenting to us Beacon High Performance Data Analysis. Please.
No, I think, yeah? Okay, good morning. I have the pleasure to introduce you to some technical development at IMDIS that we are very enthusiastic about. It links very well to the presentation about the digital twins, about virtual research, because it's, we call it Beacon, and you could see it as a next generation data lake and subsetting solution. I won't go into discussion if it should be a data space or any kind of data. You can decide for yourself how you want to call it. It's actually I'm presenting it. It's a development by the Maris team, but mainly by my colleague Robin Koyman. He's the big brain behind it. But it started with a challenge that we had a few years ago. Well, that we still have, but at the moment I challenged him. I challenged Robin. I said, we have in CDataNet, for example, we have more than 2.8 million records. I think almost 3 million at the moment. We have human interfaces, but machine-to-machine interfaces to access exactly the data you need, and not the whole files. Yeah, that is a challenge if you have these organizations with many files coming in, like in Argo, CDataNet, EMOTNet Physics, and it constantly synchronizes, and it comes in, and you can set up very complex workflows to load it into NoSQL databases or something to make it usable for queries, but it's also very rigid. So I said, okay, how can we optimize these systems to access the subsets of these collections from notebooks, from VREs, from digital twins, and how can we go from a file-based infrastructure to a kind of a data lake to get on-the-fly access to the data you want in one file. So yeah, this was our test query. So give me all the temperature data in the North Sea from 2010 to 2012 in degrees Celsius at the depth of 0 to 50 meters. And I want one netcdf file back, exactly this data, on the fly, very fast, so that I can immediately draw it into a notebook. And then still with all original metadata accessible, so that I know, even if it's parts of a file used, that I know from which original file this comes from. Yeah, and that is what Robin developed for his thesis at the time, and it evolved the last years into something we call Beacon now. I won't go into the technical details, that's too much for now, and also I'm not skilled to do it. Robin can tell you a lot about it, but it's a high-performance data lake. It's written in Rust with a little bit of C. It's very easy to deploy. It's Dockerized, and what it does is on-the-fly subsetting out of the millions of data sets. What is very, very important is that it harmonizes, even though it's various netcdf types, for example, as input or ASCII, it harmonizes that, and as output it provides you one single netcdf file back. And it allows you, via an API, to query on the capabilities behind the data, so on ranges of the parameter, of the values, search in a polygon, search on metadata. Yeah, you see a diagram here on the performance. Of course, the larger the collection is, it will get a little bit slower. On the left is the duration in seconds, actually. So if you draw 10,000 values back from millions of values, it's within 0 point something seconds. But even though when we take a subset from really billions of data points, and then we ask a file back which contains 2.5 million, it's still within 2.5 seconds. And actually the largest part is taken, and then it also has converted the units for you, and it's aggregated it to a single parameter. So it's fast enough, we think, but it can always be faster. How does it work? Because it sounds a bit almost too good to be true sometimes, but yeah, it works with indexes. So it indexes and it reads in exactly the necessary data, so it knows the ranges of the parameters that are in. It does harmonization of the file types. As I said, it has an API. It does conversion of the units, aggregates in parameters. So if there's, you know everything about P01s, about CFs, well, so if you want oxygen, you say, okay, that P01, that P01, that P01, in that unit, and yet that unit, and that CF, I see that as oxygen, and I agree to aggregate that. Well, that's the call you can make to Beacon, and it aggregates on the fly and converts it. And then as output, there's mainly netcdf, but we also have a binary format, which is even more compressed, if you want, and you can need it. And on the right, you can see the architecture with, well, drivers for the input. You can simply write in Python to index it, and then on the top, there's an API. Current state. We we have it. We have a website. You can go to it and you can visit it, beacon.maris.nl. There's a GitHub already set up for sharing notebooks and Python scripts, and we will place where we can already notebooks on existing instances. But we are still in development modus. So we're first now deploying it as part of Blue Cloud, as part of Fair Ease on the first instances, so we can control it and we can slowly roll it out. We will have instances of Argo, the CDataNet. We have some test work on ERA 5, ORAS 5 data. Emonet Physics, Antonio already presented that they are actually already deploying it in operation, even though it's version 0.8, I think, but it's stable enough. And as I said, we are creating within the project for the people that are going to work in Blue Cloud, for example, with the instances, we will create notebooks so they can adapt those and simply work with it. And we have an EOS Future demonstrator where I think Dick mentioned it already on day one to do co-location from various sources. What is a really nice example, and I got some slides from Charles, and thanks for that, we had a demo in Blue Cloud. It's something like Jupyter, but it's called Pluto. So it's a different type of notebook. But the nice thing is, and I will take you very quickly through it, you call a beacon, or more beacons, to draw in a certain subset of data. You get on the fly immediately the values back in the area that you want. Then you run diva and d on top of it, you plot it, and you have a product. You have immediately the interpolation done. And that is, yeah, we thought that it sounded like magic a few years ago, and now we think, okay, we can do it. And if you think, okay, this is a nice area, but now I want to do the same in the Western Mediterranean, you just adapt this query, you get new data in, you run it again, and you could really see this within a few seconds, I think, to run it. And that's, yeah, we thought that was an excellent demo of the capacity of what it can do. And this is this co-location tool. We have data from the CDataNet CDI collection, the full one, and the Argo collection completely, and then on top of CMEMS. So and if you then draw the slider at the bottom, and you go to 2003, and you pick a certain month, and then you can really go, you see the subsets immediately on responding to the Copernicus product. So yeah, nice example of, it's more a demo, but it's nice to see what it can do. So the current release, as I said, it's still in development. We call it 0.9 at the moment. It's actually now also adapting to support an ODV pipeline, so that within Blue Cloud we want to in the workbenches to use output from these instances from Argo, from CDataNet to do additional quality control, and that means we want to load it into ODV. So it now actually supports a format that can be loaded into ODV immediately. Yeah, we have some additional metadata handling. It also includes now dynamic chunking, because as soon as we showed it, they said, okay, can you also do it on these larger data sets, so not only on the small profiles and time series. Yeah, that works now, and it does a kind of a very clever, and Robin can tell you everything about this dynamic chunking. I kept his he likes this statement, it's like ZAR, but then more powerful and much faster. So I kept it on the slide. Yeah, you should test it out later, but it's once we release it. And the stability is constantly being improved. So what's next? As I said, we're deploying it in Blue Cloud, integrating it there, and then we're working towards a stable release that we can make available, not on a commercial license, but for academic use, available to the community. And what is important is that we want to have a community around it, so that on the GitHub, people can can work on the API, extensions to the API, so not on the core, but on the API on top. Share Python scripts that they have developed, share notebooks that they have developed, and then we'll be slowly rolling it out and building the community. So that is where we are now. As I said, you can join and connect to us via the website if you're interested. We call it pre-registration. We know we can't deliver it straight away, but at least we know that you're interested, and as soon as we have the version 1.0 available, and it will not be this year, I think, because we are just overloaded with the work at the moment. but as early as possible, and then we can share it and you can test it out behind digital twins or other applications. Thank you.
Thank you very much, Peter. That was impressive. I expect loads of questions, yes.
It usually triggers some questions, yes.
Thank you, Peter. I'm interested to the collocation, actually. What do you mean? You mean that, like in your demo from EOS Future, that you can, let's say, visualize multiple layer or multiple products at the same time? Or would you be able, for example, to extract from a model the data, the synthetic data corresponding to observation? This would be a really powerful collocation capability.
I think both. I think we can support both. I mean, in the end, what it does now, it connects to on the one that I showed, it connects to a beacon node for Argo and one on CDataNet, and actually for certain parameters. So for temperature, it aggregates it and it shows the temperatures, and then it takes the temperature product from Siemens and lays that underneath, and then you have the co-location. But if you would connect to a model that could have output as well, and you place that underneath, yeah, then you have co-location with that. Yeah, so yeah, we can test it out in Blue Cloud, I guess. I see Steve there in the back.
It's great to see this tool coming along. I know a lot of people have been waiting for this kind of thing for years. I guess the most technical, tricky question I have is, how do you deal with data versioning? So if you have a query that produced an output, and you come back and try and reproduce that down the line, how do you follow, how do you know that you've got the same versions of the data that you had when someone did it originally?
We do have the traceability. I don't know if that fully answers your question, but as I said, in the metadata behind the output file that you have the links to the identifier of the original file, the URL.
Sure.
So you do have the reference to where it came from. If that is if you come back in a month later, and that reference has changed, and you can also request the additional metadata. So in that way, you can trace if you have the same file or a new version of the file in it.
Sure, but okay, but I was just wondering, can you do like, I want to see what this query gave me 3 years ago as opposed to what this query gives me today?
No,
fair enough.
Not at the moment. Then you should actually freeze the background of the beacon instance.
Yeah, sure.
And then run it on top of that, and then run it on a new collection. And that's, I think, what we'll do in Blue Cloud. So we will take a new harvest, run it on that, and then if we have a next collection, we have a new beacon instance. So that's for now how we will work with it.
Thank you for your presentation. Question: are you planning to test your beacon system on World Ocean database?
We tested it on the World Ocean database.
Oh, good.
Yes. We it's in the Blue Cloud. We have certain virtual labs, and also in the Fair East project, and the workbenches that want to combine from different sources. And World Ocean database was high up on the list, so we will run it on 11 different data infrastructures, and the World Ocean database is one of them. And it was a bit of work, but we already. Well, just about now we have it running. So once we have it up, we will share with you so that you can have a look, of course. Yeah.
Thank you for that, Peter. That looks like a very exciting piece of equipment that's coming out down the line. My quick question for you is, do you think there will be any plans in the future for bespoke use of Beacon for aggregators such as Med and CDataNet or Ocean Info Hub, for example, where you can call on the actual data that's available in their various portals and have bespoke use where users of those portals can call on the data providers for those particular communities to call on the actual data?
What do you mean exactly with bespoke use? So that it's,
for example,
with an authentication in between?
So maybe like if you use Beacon, say for Medin, to call on just UK data, that's available in the Medin portal. And you could just use that specifically just for UK data or European data with CDataNet, rather than accessing what's available in the entire data lake.
Oh yeah, but no, you can set up on any kind of an instance on any kind of data collection, and actually,
so you can subset like this.
You can decide yourself on what part you let it index and let it run.
And I know this might be more of a future development idea, but do you think there could be potential use of maybe widget plugins for data portal systems as well, for users to use the Beacon services as well, directly from the web pages of those portals?
That would be great, and I think we can. Well, that could be part of the community to share it once the. The idea is we stick to the core, but if some add-ons are possible are created, yeah, they can be shared. Then the code.
Brilliant, yeah. It's very exciting.
Yeah, I just wanted to comment a little bit on the first question about the provenance and maintaining the information, because what we are doing in this co-development is to introduce some unique identifiers that we want to assign when we get the data also from Beacon. So then we can be able to track back to the original data, to the original data infrastructure. So in this case, we can know about the version and the unique identifier in that version. So actually we are collaborating to
definitely. And that's also why we are not fully ready with everything, but and also had to add as much, because first Beacon was only focused on the data files, but the metadata is in some cases, if you want to do a quality control, very important. So now it also needed to combine the metadata from the files, the metadata in the files, but even also metadata in the metadata files accompanying it, and adding it to it, which is was quite difficult, but it worked, and now it feeds into an ODV output. You can run it in ODV, and you can see the metadata, the full metadata, or at least a subset of the metadata that you need to do the quality control.
Yeah, this is part. I mean,
part
of the
collaboration
ongoing
work.
The requirements from the scientists that want to use this and preserve the information.
Thank you, Peter. I think we have to move on to the next presentation.
Okay, thanks.
So the speaker is Cici Yona. So Cici Yona from HTML. We will speak about the MONET ingestion and safekeeping of marine datasets.
I pressed the button for the presentation mode, but okay. So, good morning. I am Cici Yona. Of course, we've been introduced yesterday, and I will present the IMDIS data ingestion service, in which I'm acting as scientific coordinator, while Dix Hub from Maris is the coordinator of the activities and the whole service. So we heard these days about the diverse data types that exist and are measured, and we can see in this figure that there are many different data types that are collected by different platforms from at the sea, from the bottom up to the surface of the oceans, also from space, from satellites, or from lately from aerial means like drones, and All these data are used for several purposes and activities, scientific research, modeling, environmental management, several economic activities, as well as for the European Union to implement its policies, its agendas and other initiatives. And we know all that this data costs a lot. Based on previous European assessment reports, the collection by European organizations of the in situ data costs about 1 billion euros, while for the remote satellite sensing data, we need 0.4 billion euros. So we understand that it's very crucial this data to be readily available, easily accessible, and of course reliable to be used for the end users and for any applications. Today, we know that there are several existing European marine data infrastructures like SeaDataNet, Eurobis, IMDIS, ICS, Copernicus, of course, and others, which are already make a large amount of this data discoverable, accessible, and reusable, and feed the European Commission Marine Data Services, IMDIS, and CMEMS, although there are still a large amount of marine data that still are not and are not connected to this infrastructure. So the challenge here is to streamline the ingestion process from the data sources to the final repositories and data services. So IMDIS, in order to address this challenge a few years ago, in 2016, initiated the IMDIS data ingestion. And today, IMDIS ingestion is a key pillar for data sharing among the marine community. And our overall goal is to facilitate the data flow and the ingestion process from data holders to the European infrastructures, data management infrastructures I mentioned before, that are feeding IMDIS. And in this way, we're making marine data open and fair as much as possible, of course. And the approach to achieve that is that we are identifying new data holders from in the marine data collection landscape, both from public and private sector. And these data holders are not, those data holders that are not yet connected to their national focal points, or sometimes they are not aware how to do so. So we try to motivate and to support them to share the data by becoming part at the European data exchange. Also, we try to train them, to provide them guidelines, how to use the standards and the best practices that are used in IMDIS pathways and by IMDIS thematic services in order to achieve easier and faster integration of their data. Also, we are cooperating with several research projects, initiatives, and networks who are collecting and managing marine data. And we are undertaking several promotional activities in order to raise awareness about the IMDIS ingestion offer. For example, webinars at specific targeted groups, such as the offshore renewable energy sector or marine aquaculture sector, other citizen science group, and so on, who are willing to share data with IMDIS. So this is our network, the IMDIS ambassadors. Our network consists of 50 national data centers, specialized marine data centers, and all 7 IMDIS thematic coordinators, and all together promote IMDIS, interact with data holders from multiple sectors in order and ensure that trustable data are ended into IMDIS network. So how we work, how the ingestion process works. So first of all, let me stress out that IMDIS ingestion is a free and open public service to everyone in order and ensures long-term stewardship, free distribution, and publishing. In this schema, you can see our simplified workflow and the pathways that we are applying from the extended data providers towards INTMODNet. It's important here to notice that the external data sources are not ingested directly from the data source to INTMODNet services, but they pass first through the data centers, the experience data centers, for further validation, standardization in terms of metadata and exchange format, also homogenization in terms of units and used codes, when the quality is according to specific standards, then these data centers push the data towards the European data management infrastructures that are feeding INTMODNet. And the use in all these pathways of standards and best practices ensures that the data are becoming, as I said before, as much fair as possible. And you heard yesterday about the integration of all INTMODNet thematics into the central portal. For ingestion, it is foreseen this year, where we will have the same functionalities, of course, under a new interface. We operate several services. The submission service is the key service of ingestion activity, and we follow a step-by-step approach in order to simplify the ingestion process as much as possible. And for that reason, we distinguish between two phases in the life cycle of a data submission. The first phase, the initial one, is that we publish the submitted data with their metadata as is. But in the second phase, we select data that fit for use to the INTMODNet and INTMODNet stakeholders' needs and further push them toward INTMODNet. You can see in the diagram the online submission form, where extending use of vocabularies is used for platforms, instrument, parameters, whatever it's needed in order to have this to achieve ISO and INSPIRE compliance with the descriptive metadata. And also, please remember that in all this activity, the ownership of the data is transparent and clear throughout the ingestion process. And in this way, we give proper acknowledgements and credits to the originate organizations by tagging, for example, projects, query summary reports, organizations, and so on. And also, another important aspect is that we give proper credits and acknowledgement to the scientists who originate, who generate this data because the DOIs that are used for the data sets usually are connected with people's personal identifiers like ORCIDs. Another important service we operate is the viewing service, where we publish all the completed submissions, and the users can search, view, and download the data sets of their interests. And let me mention here that the viewing service has been fully integrated into the products catalog of the INTMODNet central portal. Also, we are establishing automatic exchanges with other ingestion services at European and national level. And in this way, we make more data available to INTMODNet, data that are coming from other repositories. A first very successful case is the connection with the CDataNet SINOE data citing publishing service we had yesterday. So when scientists want a DOI for the data set, we lead them to submit their data through SINOE and get a DOI for their data sets. Then we harvest automatically this data into the ingestion, and later on we push them to INTMODNet. In this way, every time the data and the derived INTMODNet products are used, the scientist gets the appropriate credits. storage. And as you heard also since yesterday, we have already finalized the same exchange, automatic exchange, with the Crown Estate marine data exchange, which is dealing with industrial survey data and mainly with offshore renewable energy data from such projects. And this data and BODC will select the appropriate data that fit for IDMODNet, and also will select the appropriate license and will send them to ingestion. In a similar way, we work so far with SINOE. IFREMER is the one which is selected, which data will end there. Let me also say a few words about the real-time operational data streams facilitation that we make for the real-time data, and we do that in synergy with IDMODNet Physics, because we establish direct data connections with monitoring operational stations. So we identify such sources, and we help them to connect and share the data with the European Operational Oceanography Data Exchange. We do that by enabling several tools and technologies to facilitate this exchange, like AirDAP, Data Access Broker, Sensor Web Enablement, and several web APIs. And the ingestion and the real-time ingestion flow is happening in an analogous way as the delayed exchange ingestion. Our progress so far, our results, we have more than 240 organizations from several sectors, academic, governmental, business, NGOs, etc. And in the left diagram, you see that we have a steady increase since the beginning, and there is potential for even larger growth through ongoing collaborations with citizen science group for marine leader data, also with stakeholders for coastal and offshore license data, where we will try to harmonize their data management procedures in order to make more of this data public available and bring them to IDMODNet. And also we will support European research projects with their implementation of their data management plans, and help them, provide them guidance to make their data fair and send them to IDMODNet. So this is my last slide, just to show some successful use cases. We already had for that. Cases, submissions both from private sectors or from public sectors or from Eurofleet projects we had yesterday. And in all these cases, IDMODNetization is acting as an online mailbox where data owners can submit their data with some additional metadata, of course, descriptive metadata for sharing with a wider community, marine community. So you can use this link, okay, in the top of the page, and learn more how ingestion is working and how you can join us and share your marine data with IDMODNet. So thank you very much.
Thank you, Sissi. We would take one very short question, and I would already ask the next speaker to get ready, which is Ingrid.
Thank you for a lot of useful information. So I was looking at the timeline, the data ingestion process. What's the minimum timeline that, as a project, we would have to consider? Like once we, as a provider, data provider, submit it, and then going through the data centers and then being, published into the IMDIS.
This depends on of course, on the data type, because as you understand, some data that are coming almost ready to us from sensors like CTD or whatever, and of course, it's easy and fast to, first of all, to publish as is in our catalog, online catalog, the viewing service. This can be done almost in few days, okay, because we have to check, of course, some metadata, but it can be done immediately. But at the second stage, for integration into IDMODNet, it is needed some more time. It depends on the data type, as I said, their quality, and you have to consider that there are some marine data that need more process for the data centers, more validation, of course, or standardization, just to apply all these standards that are needed in this workflow. But in a general sense, we try to be as fast as possible, because this is our role to make this data as easy and as fast as possible. But as I said, it's heavily depend on the data source. But from our experience so far, it can be done in a few days if the data are in a proper condition.
Okay.
If you want to get, let's say, really level 2, so elaborated, you have to work yourself and try to adopt the standards that we have, because then it's very easy, let's say, to throw to the pipes. But if you provide us with, let's say, missing information, etc., it's not possible for us to reinvent that information. And that means there is then a process. We have to come back to you and say, can you please help us? And that's why we recently we had a protocol that has been published on the EBNet portal, which gives a number of recommendations for the projects, especially to have internal data management in the projects, and that use that, let's say, to be in an early stage already apply the principles and the protocols and the standards, and then they have an output which can be much more smooth through the pipelines. Because you cannot expect, let's say, that we will, as data center, will do your work of your project, because otherwise it's a little bit like dump it and you take care of it. That's no way, no way. You understand?
We have you, isn't it? Okay, so our last talk before the coffee break is Ingrid Link-Rosenheim on data conversion processes for Web ODV. Please.
Thank you. I will try to be fast so we can go for coffee. So yeah, I'll jump this one here directly, and I guess many of you know the Mosaic expedition. Who doesn't know? It was one of the, or maybe the greatest expedition of our time in the Arctic, where polar stand was frozen in the Arctic for a whole year, and more than 100 scientists collected a huge amount of data. In this case, not so huge as compared of the data that you all deal here, but for 1 year of data in a small place like the Arctic is a huge amount. So the data was collected for atmosphere, snow, sea ice, and in the ocean, also biological data. It's already available as open source in the Pangaea long-term archive, and everyone can download, and we have Web ODV for it. So the Mosaic Virtual Research Environment project offers different tools for the analysis of the Mosaic data. One of them is Web ODV, that many of you already know, and also know that is based on ODV, which is a well-established software. And however, Web ODV is more interactive because it's accessible via browser. You don't need to have exactly a computer to deal with the data. You can deal with the tablet, you can look at the data through the cell phone, even if it's not so nice to do it right now, but I guess we are working on making it better. And also in the Web ODV, the data is already there, so you don't have to go to Pangaea and search for this data. The data is already uploaded, or most of it, not everything, but most of it. And the data is also kept up to date with the Pangaea, with metadata and citations and everything. So Web ODV and FAIR data. So why Web ODV also can be inside of the concept of FAIR data. The data is findable because every data set inside of a collection contains the link to that original file in Pangaea, so you can find it easily. It's accessible because the data is in collections, so instead of downloading for one collection, I don't know, 89 data sets, like some of our data, you can go and download one collection that's already right there, containing the metadata and everything. It's interoperable because I can download in 3 different formats, which are already there. So text, the ODV format that many of you like, and also in NetCDF. And it's reusable because I can send my analysis and my visualizations to my co-authors. they can reproduce those analyses and visualizations, make their own, and they still won't interfere with my analysis also. So the data, the Mosaic data is divided in categories in the WebODV. So atmosphere, biogeochemistry, interdisciplinary collections, master tracks, model, and so on. And those categories can change over time if it's necessary. To put this data, the Mosaic data in WebODV, we had to develop a workflow because we need to do an advanced search on the Pangea archive, filter this data for data that cannot be visualized or analyzed with WebODV, like maps, plots, images, videos. There was a lot of those during Mosaic. Then the data that stays there that can be analyzed, we download into our servers, and we perform conversions. So the data is downloaded in the tab format. That's a standard format for Pangea. The metadata is also downloaded and citations. And those data are then aggregated where metadata and data are in the same table. After this data collection, some of the data are also converted, or not really converted, but aggregated into interdisciplinary collections. But some data need some special conversions. Then the final conversion into ODV format is done. The data is checked and made available for everyone in the WebODV. This is the list of metadata. I think for many of you, this is really important. And for me, at least, the ones in red is the ones that guarantee the transparency of our work and the traceability of the data to the Pangea and to the authors of the data. Why do we need special conversions? So Pangea is a data lake. And in Pangea, the authors, the data creators can submit the data in whatever format they want. So if I want to submit it as a text file, like the data here on the left side, I can. If I want to submit it in the tab format, which is the standard way, I can. I can submit netcdf and so on. However, to put the data in WebODV, I need to have this data in a text format readable by ODV. And this is our special conversion. So it can be done because of the data format, or because even if the data is in the tab format, it's not really well readable by WebODV. And that's the case in the left, when I have too many columns, and I could have this data in fewer columns. So the final data conversion is done by bash scripts. Actually, the whole conversion is done first in Python. But for the final conversion, those are in bash script. And after the tests, and being guaranteed that everything is correct, that the data is correct and can be analyzed without any problems, it's then uploaded into WebODV finally. This is one section plot as an example of what we can do with WebODV. And this was done by Sebastian together with the data authors. So Sandra Tippenheuer was one of them. And I hope you like to play around, and thank you for your attention.
Thank you very much, Ingrid. Any questions, Hans? How does this relate to the platforms that we have heard about here all the time? eModNet, Beacon. How will this come together at the end? Is that planned, or is it really specific an application for the Mosaic project?
It's a specific for the Mosaic project, even if there are other web ODVs that are for eModNet and others, but this one is a specific for the Mosaic data. It's an opportunity that people can look into this data without having to programming before. Because not everyone outside of academia has the knowledge of programming to really look at the data, and maybe even teachers in the school could use this data to teach the climate of the Arctic to their students. So it's...
And that was a big part of Mosaic. I followed it online while it was ongoing. It was really great. Okay. Any other comments, questions? Otherwise, I guess Helge wants to say one word. Will you give us the timing for the coffee break online here, or do I have to? Yeah, okay, half an hour coffee break. And thanks again, Ingrid.
I want to replace.
Okay, so let's start again. So the next speaker is Henning Stenansen about the Aqua Infra Interaction Platform, access to fair multidisciplinary freshwater and marine data and services to restore our ocean and waters by 2030.
Oh, it's a Windows computer. I hate Windows. Yeah. Yeah. Yeah, well, this one. It's
that one. Difficult with two choices.
Yeah. I'm not so familiar with a Windows computer, but I think that I can manage it. So oh. What should I use? Should I use this one? Yeah. Oh, it's, yeah. The Aqua Interaction Platform, access to fair and multidisciplinary freshwater and marine data and services to restore our ocean and waters by 2030. That's the title of the project. And perhaps I should, yeah. The overall objective of this project has been to, or is to, develop a virtual research environment equipped with fair and multidisciplinary data and services that supports marine and freshwater scientists and stakeholders restoring healthy oceans, seas, coastal and inland waters. I think I nearly have it in my mind because I've said it so many times. This about making healthy waters by 2030. It is has been a very important guideline for the project since we started preparing it nearly 2 years ago. I think that in my presentation I will mention topics which has not been mentioned so much during the previous presentations, the Monday and Tuesday. But anyway, we have made a technical framework to enhance cross-domain research, enabling seamless discovery and access to marine and freshwater data with interdisciplinary discovery services. And I was really happy when I listened to, I think it was the morning presentation yesterday about the further development of EMODnet. I'm not talking about the inclusion into the European Commission of the program, but that he mentioned freshwater data. And as a scientist, I have always thought it was a bit special why freshwater scientist was in one department and marine scientist in another department. Because fish and bacteria or chemical substances, they do not stop at the coast. They are flowing through, and if we want to have healthy waters actually we had the ambition to have it by 2020 as planned in the MSFD directive, but now it's moved into 2030, and when we come to 2030, we will for sure also extend it to 2040 or 2050. But anyway, we cannot save the oceans without considering the whole freshwater system and also the human activities taking place on the land side. Just think about eutrophication. I have mainly been working in the Baltic Sea and the North Sea. I think perhaps I'm even the first one to mention the Baltic Sea, but because this has eutrophication as a very good example. They are coming from agriculture and other human activities on land. Not only, but they are the main sources. But we have developed this architecture, and it was just updated last week. So, and we have also realized that we are in a very dynamic process. Things are changing. We heard earlier today about Beacon, a new technology being developed by IMDIS, and there are coming new initiatives regarding EOSC. When we started making the proposal, we didn't know what was EOSC actually about, how would it be further developed, and now there are also new policies about EOSC. So it's really a dynamic process to work within, and but our main aim is actually to develop a research infrastructure to support the scientists to save the healthiness of the oceans. Very important thing is that you can find the data you need, that they also available in some way, and we have a very open approach. It means that we are not only focusing on a selected set of big data repositories like EMODnet or Siemens, but we are, or ISIS, but we are actually looking into many different kinds of data. And especially when we are looking into the freshwater side, the inland water side, it becomes much, much more complicated. When we are talking about marine, we can say, okay, EMODnet, Siemens, ISIS, and similar, they are providing quite wide data sets. But if you're looking into the freshwater, there are only this WISE handled by the EA as part of the Water Framework Directive reporting system, the Water Information System, and it has two dimensions. It has freshwater and also marine, but this is the only one. Most of the data, they are in the different countries within Europe, and I believe that if I'm looking into Germany, there is a system for each Bundesland. If I am, so this is of course very, very complicated when we are also trying to find access to appropriate data, and we are working quite a lot with this, and we will for sure make success on this. And but of course we have to look into ontologies, and we have to look into different means of the wording, different ways of handling the data, and this actually complicates quite a lot. Data harmonization and integration. Yeah, here we can see the Baltic Sea, and we have, for example, the catchments for the major rivers to the left of the Baltic Sea, and then we have to the right, for example, NOTS data. If you want to find out how many people are living here, to have some assessment of the pressures, how large industrial or agricultural activities are taking place in the different areas. And combining this is not so straightforward, but we are working with this, and yeah, moving forward. We have several use cases or case studies, or how we will call it. It's more or less a discussion also as the previous data. He will not have any discussion about data lake or data space. I've totally avoided this. We are using data space, but we are not totally sure that this is the right term. We can have a full symposium on discussing which term to use. But the use cases, they are working, they are real marine and freshwater scientists working with problems in their areas. We are also developing a interaction platform. It's still under development, and the virtual research environment. We have now found out that we will base it on the Galaxy platform. We have done a lot of analysis to find the best one, and this is where we are looking at the moment. And my colleague Merit Burman have a poster over there. Yeah, a poster over there, and it's number 161, and there you can hear more or read more about our work on the research, virtual research environment. A very important part of the IMDIS are also that we can convince the research communities broadly, not only within the consortium. It is a struggle enough to convince them about how important IMDIS is, but also this about learning about FAIR principles, learning how to publish your data in an easy available way. So we have a lot of training or planned training and activities to enhance the capacity. Very few. The combination of the technical methodologies underscores Aqua-Infra's commitment to providing a robust, user-friendly, and innovative environment that enables and propels forward the research in marine and freshwater sciences. And the next steps comprises the further development of the data discovery and access service and the Galaxy-based virtual research environment, and adapting our services to the ongoing developments of the European Open Science Cloud. Thank you.
Thank you very much. Direct questions, anyone? Could you elaborate a bit on why you chose this Galaxy platform as the underlying technology for your...
I have not been so much involved in exactly this dimension, but of course as coordinator and also I have been following it, but there has been, I was listening to last year's IRSC conference. There was a good presentation from Galaxy, and I saw it and thought about, okay, they also contacted me, and they have also contacted others, so we could be familiar with this, because in a way it's hidden outside perhaps some the technology world. If I am asking a biodiversity scientist, what do you think about Galaxy? He will never heard about it. He thought, hey, this is something in the universe. So it's but we have found out that this is the most appropriate one. We can also see that there are some challenges. For example, is a full support of our studio, for example, and so we have seen different challenges, but we also try to work together with them, and we have created our own instance of Galaxy, so we are not totally dependent on if this falls down or so. Yeah.
Okay, thank you. So good. Congratulations for the presentation. I have I'm coordinating the eModNet chemistry a lot, and we have a task on the collection of data from riverine, so riverine inflow of really on contamination and eutrophication and so on. So how would you see the collaboration, or do you? How can we? I mean, I think that we could have a similar task in also getting in touch with local authorities and so on, because I really share the concern that you have.
I really appreciate your comment, and we are clearly interested in collaborating with you, and we have also got some invitation from eModNet to collaborate more. But we have been extremely busy during the last, so it's on the waiting list. But let's be in contact, and because I think we can create synergies working together on this. Was this an answer to your question, or?
Yeah, we will be in touch.
Thank you very much. That was a really interesting presentation. Thank you for that. I just have a quick, somewhat technical question. I noticed that you publish socio-economic data on the system, and I was wondering, do you publish these as non-geographic data sets, or because they generally don't have a spatial component to them? And if you do, is there a standard, an existing standard that you follow for that? Because in my searches for such, I've never actually found any standards. So I'm at a point where I'm actually drafting my own.
Yeah, thank you for this question, because it's my main research interest. So, of course, if you remember the two maps I showed you about the Baltic Sea, that you have the administrative. Okay. You have the administrative boundaries, for example, for knots or local area units corresponding to municipalities. And then you have the catchment areas, from the big ones to the sub-catchments. And of course, if you should really identify the drivers and the pressures in specific sub-catchments, then you also need to know what are the human activities exactly taking place there. And we are working at the moment with methodologies involving asymmetric mapping, and we will submit a paper very soon, within 2 months or so, with our first efforts to use current land use combined with others. But this is not so straightforward, because it seems that there's also some spatial. It is quite difficult, but we have also thought about perhaps using artificial intelligence, but it's not so straightforward, because then you cannot make the same, cannot get the same result again. Because it's data driven, so you cannot control what's going on exactly on if you are using a neural network, for example. But we are really working on this, and the data, of course, will be available on the AquaInfra platform, but they could also be available, for example, through the EMODnet, so yeah, that of course we have also thought about Zenodo, etc. So, but this is a very, very important task for us, because in order to estimate the cumulative effects of the pressures on the ecosystem, yeah, you need simply to have also the whole pressure generated from the start of the river through the river system to the coast and spreading into the sea.
We three should have coffee. Okay, thank you very much once again. I believe that AquaInfra is a sister or brother project with Blue Cloud 2026, and Dick will now tell us everything about that. Isn't that right? Not the secrets, of course. Please, Dick Schraap.
First, I have to find it, of course. 1, 2. Oh, there's a lot here. There's a, yeah, it's not easy. Yeah, I got this one. This is the good one. Yeah. Okay. And then we need this one, eh?
They look empty, just saying.
Huh? It's empty?
Are they all empty?
I don't know. It should not be empty. That's strange. It's a big file. Maybe the computer is quite slow.
Oh, that could be it.
Yeah, it's empty. Not responding.
There you go.
Yeah, we got it? Can you see it? Yeah, okay. Let's see. Okay, yeah, I want to give you a presentation a little bit about the Blue Cloud 226. And in fact, I start with the Blue Cloud pilot, because that's the base. And indeed, it's we are a sister project with AquaInfra. So we are doing the marine, coastal, and AquaInfra is more doing, let's say, the fresh water. And of course, there has to be a connection. And both of us, let's say, we are working for the mission Ocean, which also has inland waters. If you look at the start, so we started with in 2019 with Blue Cloud. And the idea was to have a flagship project for G7. In fact, to look at the power of, I would say, the cloud-based open science. And to see how you can, with doing this, let's say, how you can tackle better scientific challenges, complexities with multidisciplinary problems and issues. And then in support, of course, of, let's say, the marine environmental management. And therefore, we said we're going to deploy a cyber platform with Smart Federation, both of the data, the algorithms, as well as the computing resources. And then also we work for the, let's say, under the flag of the European Open Science Cloud. So the idea is that we could make a blueprint, which is very appropriate, a blueprint for a marine thematic EOSC. And one of the philosophies in the project was we do not bring the marine community to EOSC, but we bring the EOSC, let's say, principles to the marine community, because then it has much more chance to survive and to thrive. The principle overall is that we have 3 levels. One is getting, let's say, upstream, trying to get discovery and access to all the data resources, because that's the basis, and make them, let's say, standardized, that you can bring them together. Of course, using then standards like OTC, ISO, etc., but also, of course, our own community standards like vocabularies and formats. And then on the other side, once you have access to all this data, do more with the data for science, analytical processes, and set up this thriving, I would say, virtual research environment in which you can find many tools and functionalities to be able to do more with the data and combinations of data, bringing different scientists together from different disciplines and then work on a collaborative way to try to solve many of our big questions. In there, we went for a heavy, I would say, heavy team. So we have many of the research infrastructures on board, which are in the S3 calendar. And also we have AIMOTNET and Copernicus on board from the start. And that means that we, and on the other side we have e-infrastructures, which like UDAT and also EDI is now on board. And we have Vecchio and we have D4Science, which is from CNR. And altogether, let's say, you have quite some heavyweights in this case. So you can break the ice, we say. The three key exploitable products that we are looking for are the Blue Cloud Data Discovery and Access Service, the DDIS, which is a federation of all the existing repositories which are useful for our purpose. Then we have this virtual research environment, and last but not least, we have virtual labs, which in fact are demonstrators to see how you can combine data and virtual research environment facilities to do science. If you look at this federation, the data discovery, we have on the top bar, you see, let's say, the repositories that are in there. And what we tried to build, or did build, is in fact the first prototype of a common discovery and access to all the data behind these systems. And these systems are quite different. They're in biology, they're in chemistry, they're in say, physics, and also in genomics. And altogether, at that moment, they had about 10 million objects. But we went for a two-step approach, that we say we do first the discovery at the collection level, an aggregated level, and then once you know which of the infrastructures has, let's say, interesting data sets, then you go a level deeper and you use extra criteria, which are now more specific for that specific repository. And this way you can more or less drill down to the data, and then there is a mechanism, a cloud mechanism, to retrieve the data, put it in the cloud, and make it ready for you for downloading, or to push it into the virtual research environment. And here is, let's say, an illustration of that process, the two-step process. But I will go a little bit faster because the time. Then we have the virtual research environment, but that's a collaborative environment. But afterwards, Massimiliano will tell much more about this, much more details. So I will just skip this part, but because he is I think two slides behind me. Then we have, we also made, let's say, we made several virtual labs. And also we did a hackathon, inviting outside external researchers to work with the environment, to work with existing virtual labs, but also to develop their own. And that was quite interesting. And also you have a lot of synergies with other projects, let's say, in the research domain, especially to get this, let's say, to get an ecosystem of virtual research open science. And we have with several of these projects, we have arrangements, let's say MOUs or other types of arrangements. And they are invited to make use of the facilities that we offer. We have a lot of computing resources also that can be used. And this way you build a community, more or less, let's say, an open science community in the marine domain. Also we made a roadmap, because it's very important, of course, to inform all the stakeholders, especially those that are going to, let's say, if you want a perspective in the long run, you need to also involve all the stakeholders from top to down to the bottom up, and top down. I mean, especially then, let's say, decision makers and funding agencies. And that's why we, from the day one, we have quite a heavy promotion, marketing, involvement, engagement with stakeholders at all these levels. And that means that when the project was only a few months underway, already a lot of people knew about the name. And if you ask them, what is it? I don't know what it is, but it's very interesting, it has to go on. So that was good, that message came on. But then we made a roadmap, let's say, a planning a little bit, what can we do in the coming years. And based on this, there was a new call from the Commission, in fact, the present call, which we could then convert into a proposal, because it was exactly what we had sketched out in our roadmap. And that was, that's how you can involve your stakeholders to take the right decision, I would say. And that was very helpful for us. And now we are in phase 2 of the project, look out to 26. That means that we scaled up the operation, so we have more parts on board. Also, we are, you can say, somebody said I'm using it a lot, but I always want to go wider, more horizontal, and I want to go deeper, that's vertical. Those are the two things how I build projects and infrastructures and try to continue. And that's something that we also did in this way, because we add more functionality, we add more, let's say, repositories, we add more researchers, we add more virtual labs, we add also some other things, which I will explain. But this way, let's say, we're able, let's say, to go to in fact deeper and wider and to serve more purposes, and also make it easier, or let's say more attractive for the stakeholders. Of course, again, to make a roadmap, which then sketches the situation to 2030, And that could then be followed by hopefully by the stakeholders to give us also that opportunity as living on for this infrastructure. One thing is that we are doing is that we have, we are harmonizing also in the second phase. Because we have this data discovery and access service, and now we want to do semantic brokerage in there. And in fact, you heard already a lot about vocabularies by Alexandra, for instance, with the semantic analyzer and also semantic broker as a result. And that's something that we are including. And that means that we are working with these so-called blue data infrastructures, let's say the repositories, to improve their services. Because we learned from the first one that they have APIs, they have web services, but they are not always perfect. And in many cases, they are serving out simply plain text, while internally they are using vocabularies. And we want them, let's say, to also make the semantics more visible in the web services. And that's something that means that we work on the base together with the BDIs to improve their services, and on the other side, on the top, to be able to handle those semantics and also make them more, by mapping, make them more interoperable between them. And that's, of course, in favor of the users, because you get them more fair data and more fair metadata. Also, we look into, let's say, having additional BDIs, which you can see here, EMSO, CIOS, Internet Physics, and Magnify. And also, we are looking at what Peter just presented, let's say, how to develop data lakes and subsetting services. And therefore, in fact, we follow this development of Beacon. And we had several workshops as part of the Blue Cloud, and where we demonstrated, tested, etc. at Beacon. And based on this, there is now, let's say, a plan, which we just delivered, this 2.4 as a deliverable, which tells you how we're going to deploy data lakes, first of all as input data lakes, so that they can be used for the virtual labs and the workbenches to have an easier access to data sets that they need on the fly for their analytical pipelines. And that's why you have now a landscape sketched, landscapes of beacons for different monolithic repositories. But later, we also have so-called workbenches, and there we have to merge and harmonize several of these. Now then, let's see, this is something I skip, because that's what Marciano will explain, that we're going to expand the virtual. And then we also have a task force in the project, together for, let's say, tuning with DTO development, especially with Edito. And because the idea is, of course, that the Blue Cloud is developing, can be seen as an incubator, but can also be seen as a delivery of new added value data sets, let's say with data lakes. And that's why we are looking together, let's say, how we can make bridges between the Blue Cloud and the Edito infrastructures being developed, and how then the work that we do can go from, let's say, an RTD level into a more higher TRL level, being productive as part of the DTO. This is now the consortium, quite a big consortium, but everybody is quite lined up now. Let's say that, so we're working in the right direction, and there's a lot of, I would say, I always call it a nice spirit, let's say team spirit, and people are very interested in innovations, and that's something that we need in this project, because it's an incubator. Any questions? I kept it short, I hope.
Thank you, Dick. Questions, of course. Then I will ask you, because I am also starting up a project now with 4 sister project or sibling project. So, so how do you work together when you have these kind of sibling projects? I noticed that you have a lot of outreach to other projects, but Aqua Infra was not on it. Yeah. So can you comment, or maybe both of you?
No, normally, let's say I work in so-called cells. So you have different cells. People have certain goals. They do developments. At the same time, you try to have some common principles that you try to plant in all these cells. And this way, common standards, of course, for metadata and data. Use existing repositories, these kind of things. That's always one. Another one is that we say, if there's a technology being developed on the left and you can use it on the right, let's get together and try to use that. And this way you get a lot of cells with very active, let's say, groups. And in the end, it's like a jigsaw puzzle, it all fits together. Another thing is that we always start with a so-called black box. So we have a target, we have a black box. Then we start dividing that black box in little black boxes, and they become more and more transparent over time. And then everybody has the feeling, now I know where we're going. And then you go in acceleration mode. And that's the way to do. But it's just a matter of management principles, I would say.
Okay, thank you for that.
Okay.
Anyone else? You have a question, Christine? No.
Okay, no.
There we go. Thank you, Dick.
Okay, the next speaker is Marie-Josée about the Galaxy platform as a groundbreaking fair tool for Earth systems analytical workflows.
Okay. How do I put in? Yes, this one and then full screen. Full screen. Okay. Okay. So, hi everyone. So I'm here to present you a bit more about the Galaxy platform and the work we're doing within the FERIS project for the Earth Systems Analytical Workflows. So my name is Marie-Josée, and so first I will present you a bit about what is FERIS, because we heard a bit about it, but we don't have a presentation yet. Then what is the Earth system, why we're using Galaxy, and the different good practices and tools and workflows that are available in this platform. So, FERIS is a European project of EOSC. The aim is to build an inter-domain digital architecture for distributed and integrated use of environmental data. And here I will present you more the part about virtual environments, because this is where Galaxy fits in. So the Earth system is a complex and dynamic system that encompasses the interaction between atmosphere, oceans, land, and biosphere. For FERIS, we decided about 5 pilots that will represent this Earth system. So we have coastal water dynamics, Earth critical zone, volcano space observatory, ocean biogeochemicals, and marinomics. If you can learn more about these 5 pilots on the FERIS website, or some of the representatives of these pilots are here today, and you can go ask questions to them. So, why Galaxy? So we chose to use Galaxy to represent and analyze these different data, heterogeneous data from the Earth system. Galaxy is a community-driven platform that is already popular in other domains, so for instance bioinformatics, but also in climate and ecology domains. It's totally open source, and it's really based on the FAIR principles. So this is what it looks like. You have on the left side, the blue panel, the different tools that are available on Galaxy. They are divided by sections that represent the different compartments of the Earth system. On the right side, I think it's the other way around for you. But yes, so on the left side for you, you have the history part. So in the history part, you have all the different analytical steps. What? Ah, no. Okay, so the green box. The green box is for the history part, so you'll have all the different analytical steps of your analysis. So you can find here the data that you uploaded, the process that you done on your data, the different visualization that you've created. And in the middle panel, this is easy, you can find the different formula where you can input the parameters that you will choose to run your tool. And you can also have in the middle panel the different visualizations. So for instance, if you created a graphics, you can visualize it here. If you have a tabular or a CSV, you can see it in the middle panel. So there is a lot more features here, but this is the quick overview of how it looks like. So a bit more into the best practices of Galaxy. So as I told you, it's a fair tool, and it is based on 3 main principles. The atomization, so the idea is instead of bringing a huge script, so when I'm talking about tools, I'm talking about scripts like Python scripts, R scripts, it's totally language independent. So instead of bringing a huge scripts, you can divide it in elementary bricks, and then you'll be able to change these scripts one by one. Each script needs to be standardized in order to have generalized tools. And once you're happy with your tools, you can then bring them to peer review, where the Galaxy community will make sure that your tool is the best as it can be. So in a bit about the developer side, but I will really go quickly. On the standardization part, you have what we call a wrapper. So this file is an XML file, and it will do the links between your R or Python scripts or any kind of language and between the user. So you can see that we have the formula where the user can input what he wants, longitude, latitudes, for instance. And you can see the same the information that are in the XML files, for instance, the green box and the orange box that you can see. So here you have the standardized things that need to be put, for instance, an ID, a name, a version, the different input outputs, the libraries that your tool is using, and everything. So this is a bit about the user part. So there are many kind of tools in Galaxy, but we can divide them in 3 main branches. You have the batch tools. So these tools doesn't require any informatics skills. You can come in, put your inputs, and just run the tool without having to know anything, and it will bring you the output that you're wishing without to know anything. Then you have the JupyterLab tools, where you can launch a JupyterLab from Galaxy and have the environment that you need or the set of notebooks that you need. So for instance, there are JupyterLab for DivineD, Holovis, Copernicus Data Space, Ecosystem, OpenGeo, and so on. And finally, we have the desktop tools. So from Galaxy, you can launch a desktop tools like you would launch it on your computer, but you don't have to install it. So this is way more easy. And you can have, for instance, QGIS or Ocean Data View. So I told you about atomization, so I'm coming back a bit on that. So for the atomization, the idea is to divide your script in elementary bricks, and then you can create workflows with Galaxy where you can chain any tools one by one. This way, it's easier for the user to understand your analysis. It's also easier to combine tools and create different analyses. So one user can come and see this workflow and say, yeah, okay, that's nice, but I want to use another tool, and you can chain everything like you want. So here, for instance, you can use, I will introduce you this workflow for later on, but this is the coastal water dynamics mock-up workflow of ferries. So this is an example of a way more complicated workflow. And finally, one of the Galaxy features is that you have the Galaxy training network where you can find all the tutorials and different guides that will guide you through your Galaxy journey. So from the creation of tools to the creation of workflows, or even on thematic subjects. So the main idea of Galaxy is that if you're a developer, you can create your own tools, or if you are not, you can ask for someone for help to create your tools. Then you can set up your own workflows with the already existing tools in Galaxy. And finally, you can write a tutorial to explain what is your analysis about and how to build it. So our tools in the workflow in ferries. So first, the Ocean Variable Study one. So it's the one that I just showed you. So you can bring your aggregated data set that contains all unrestricted Edmond chemistry data on eutrophication and acidity, and that covers the Mediterranean Sea, into Galaxy. Then you can run the workflow, and from there, the data will go into ODV automatically, where you can go then into ODV, subset your data, and then it will close the ODV, launch DivineD, the JupyterLab with DivineD, create a climatology, and finally, it will launch the last tool, which is again ODV, where you can visualize the phosphate variable. So for instance, when you use this tool, this workflow, you can have the training that goes with it in Galaxy Training Network, and when you launched it and run it, you can also extract it, for instance, and share it with other people, and extract it in Rockrate, for instance. So this is the output that you can find of your workflow. And everything that you've done into your workflow can be seen into the Galaxy interface, and all the steps are in your history. And so here is an example of the image that you can see in the middle panel. Another example is the Argo workflow. So this workflow allows you to retrieve Argo data, biological, chemical ones, or physical ones, variables of the ocean. Once you've retrieved your Argo data, you can then go into PenGeo tools. So PenGeo is an ecosystem of tools to help researchers analyze the data. From these PenGeo tools, you can clean, subset your data, extract the metadata. And once you've done this part, the workflow will automatically launch ODV with your cleaned data, And then you can go into ODV and do your visualization and your different analysis that you want to do into ODV. And so, yeah, you can, that's already said. And then you can directly have the outputs of what you've done into ODV into the Galaxy interface. So the same here, you can see an example of what the tutorials look like. You have some boxes about hands-on and some images that will guide you through the full analysis. So what you need to keep in mind is that Galaxy is an open source platform for fair data analysis that enable users to use tools from various domains, and then you can plug them into workflows. You can also use interactive environments such as RStudio, QGIS, Jupyter Labs, and you can plug them also with other tools and create your own workflows. Everything can be shared and published. You can also create visualization and work with other people. And to ensure the reproducibility, Galaxy capture the necessary information of your analysis to repeat and understand all the data analysis that you've done. So the Galaxy community is really strongly involved into helping the researcher into their analysis and their work. And so there are a lot of collaboration and help that is possible to have. So don't hesitate to reach out, and I'll be happy to help you. Thank you.
So thanks, Marie, for this very nice presentation. Do you have question?
Looked like a very nice tool. I'm going to try it. But only one question I have is, have you said anything in performance? Is performance issue that is...
For the performance issue? I'm not sure.
Yeah, performance issue. Is there any performance issue that is...
So Galaxy is, it depends on how you use Galaxy, because you can deploy your own Galaxy on your infrastructure, but you can also use the one that is available on internet. So this one will be based on a cluster that is fine in Freiburg. So each user has its own storage place capacity on Galaxy for this part. And there are multiple ways to distribute the calculus to other kind of clusters. We call that pulsar, which is used to distribute everything so that we don't have everything on the same place and it takes too long. But if you have your own, the Galaxy deployed on your own infrastructure, that is up to you to manage.
Thank you. Thank you for the nice presentation, Marie. I would like to, so I love the workflows, and I wonder if they are machine readable and shareable, so somebody can actually do the reproducibility of what they did.
Yes. For instance, the workflows that I showed you are available. If you go into Galaxy, you can find them because they have tag names. So if you search for Earth system, you can find it, and you can then change anything that you want into the workflows. But you can also, if I do one and I don't put it publicly, I can directly share it by a link with you. And it's also extractable in Workrate. And I didn't use it yet, but I think there are some ways to directly send them to Workflow Hub, for instance.
So they have unique URIs and they resolve to arrow crates?
Yes.
Okay, that's great. Thank you.
Thank you very much. If not, I guess we move on to D4 Science with, if I'm right, with Massimiliano. Is that right? Welcome.
Sorry. Okay. Just trying to figure out how to put it in. I can find it. Can someone help to put it in full screen mode, please? Sorry. No, it's okay. It's my fault. I'm a Mac user.
No, it's fine. It's a PDF. It's here. It's here. No, it's not. It's in full screen maybe already.
You can't find it either, huh?
It's not active.
It's not active.
Are we maybe in full screen mode already? No, we are not.
Maybe I've opened the wrong. Let's try another. Open with.
No,
wait.
That's right.
Yeah.
Yeah. Okay. Now it's online. It wasn't active.
Okay. Sorry about the waiting. As I said, I'm a Mac user, and I'm a bit dumb with. Sorry. Anyway, so welcome to the D4Science presentation. So in this presentation, I'm Massimiliano Assante from the National Research Council of Italy, and I'm going to present you a solution for advancing ocean science through collaborative data analysis. So D4Science, besides being the, let's say, Blue Cloud VRE platform enabler, as you know, along with other projects, so you will find out what it is. So let's start with a very short description of what is D4Science. It is a digital infrastructure for collaborative scientific research combining over 500 software components into a coherent and centrally managed system of hardware, software, and data resources. What we're trying to do in D4Science is that we have the goal to promote open science practices through the operation of this digital infrastructure. And we achieve this by, I will try to explain this with this slide here. So we leverage external systems in terms of data storage, but also cloud-based infrastructures, and we expose them in what we call a common unified space of resources. So if you look at this slide here or there, in the middle layer, there is a sort of abstraction layer where we, expose all these hardware and software and services and data resources in this common unified space. And in doing so, we are able to serve diverse community of researchers and to provision tailored service and sharing tools. On top of this, the way that we make accessible these resources is through web-based, on-demand environments called virtual research environments or virtual lab. So if you're more interested, there are some pointers for some publications on the web. So open science. So as I said, we have this goal of supporting open science practices when you perform some scientific research that is using the D4Science infrastructure behind, for instance, in Blue Cloud. So if you see in this slide here, there is a prototypical, very simplified scientific research workflow for data-driven, research. So it starts maybe, you can start basically from anywhere, but suppose that you have a research challenge, and so then you have to, start collecting your research data, and then maybe you have, to import your model, your software into the infrastructure. Then you have to execute your model, and then it starts the research process, and in the end you get, some research data as output of your data analysis, and which maybe they deserve publishing, and they are scientific results, and then it goes on. So what we're trying to do is to support the whole research life cycle as shown here by enabling the repeatability and the reproducibility, the reuse and evaluation of research processes, active collaboration among users effective sharing. And in doing also all this, we really one of the other goals is to maintain the provenance and attribution of the research that is carried out within a VRE. In doing so, we adopt this, we call it as a service approach, and of course, a number of standards for implementing the interoperability and economy of scale, of course, to reduce cost. As I said, D4Science is a federated digital infrastructure. Currently is located in 4 sites in Italy. One is Pisa, it is our headquarters. And then we have 3 sites at GAR, that is the Italian National and REN. And D4Science is owned and managed by CNR, and it is, supports also S3RIs, national European projects, and also international initiatives. So how does a community can get a VRE on D4Science? So I take this same picture as before. So imagine that you are community A, so you can get a subset of the resources. And it is D4Science that does all the job for you, and then you just obtain the resources automatically assigned for you. When we talk about marine and ocean science and the support that we do in this field, so as Dick presented, we contribute heavily on the European Open Science Cloud for projects. We started in Blue Cloud, the pilot, and then of course we are involved, as I said, as the VRE platform of Blue Cloud 2026. But in the past, so D4Science is not new. It started, I think, more than 15 years ago. And we started with this iMarine project in collaboration with FAO and IRD and other partners. It was more about fisheries and ecosystem approaches for fisheries. Then we were involved in Blue Bridge project. And then we also did some experimentation with aquaculture companies in a project called Perform Fish. And then, of course, the Blue Cloud path that you just heard about. So in a very few words, is one common place to collaborate, to share, reuse, and reproduce, and reproduce your science. In terms of tools that are available for collaborative data analysis, so we, as D4Science, do not only provide the cloud resources, let's say, but we also provide a number of services that we call VRE core services for open science. So we have, for instance, and they are all interconnected among them, and it is very easy to make, to make one service communicate with the other. So for instance, we have our cloud storage solution where you can store your data. We have the analytics platform, and I will describe it right now. And we have a way for members that work in a VRE to collaborate and communicate. And of course, we have also a way to publish the results of their computation so that the science and the scientific result are accessible as early as possible. Okay, so you don't have to wait until the publishing and all this. So in terms of data analytics tools, so we have a highly configurable JupyPy environment, Jupyter Lab, many of you asked. Why highly configurable? Because we are able to, configure your JupyPy server with the libraries and the programming language that you need, the libraries and everything that you need to execute your notebook. Same goes for RStudio. And of course, it is possible to deploy your Shiny applications in R. Now you can also do it in Python on the infrastructures. We do have a our own solution for an analytics engine is called Cloud Computing Platform, and it supports the import of models in the infrastructures and the running of your models, and in all doing this, it's, manages the provenance and of the the executions and everything. But of course, you can come with your custom service or applications. In this way, like many of us do, you can Dockerize your applications, and we can manage and follow you and supporting into the integration into infrastructure with Docker. This is just an example for publishing an item. So we have a service dedicated for when you have something that you want to share with others in the VRE. It is basically a catalog, and where you can you can specify exactly the metadata profile that you want to use to, let's say, describe your scientific product. So this is also possible. In this case, this is a FAO aquatic species distribution map. So as soon as I said, 1 minute, okay, and then so my last slides. A picture is worth more than 1,000 words. So this is some example of virtual labs at a glance. So you see on your right a notebook. It is possible to execute notebooks. On the bottom where you see Italy and all Europe, Spain, and that is a custom application that was Dockerized and imported in infrastructure and accessible through a virtual lab in Blue Cloud. And the nice thing about this application is that behind the scenes, they have imported their model in the infrastructure, and they can call their model from the application, get back the results, and display it as they wish in the application. Here you find Shiny App and other custom application they use, for instance, GIS technologies behind. So, for instance, GeoServer or GeoNetworks or map servers in general. And I'm done. Thank you very much.
Thank you very much, Massimiliano. We take questions.
Oh, thank you for your talk, Justin Buck, NOC. The work that you're doing about reproducible research and reproducible results, it's critical in everything we do. Do you also enable the credit, so where you've got the shared resources and the reuse of the underlying resources that are provided by other people, do you enable credit to those creators and credit to the originators of that work when it gets used in other publications?
I'm sorry, can you repeat the question? I didn't... Yeah.
So in addition to the reproducibility work, which is critical, there's a library of shared resources and shared data and shared services that are reused by other people. Do you enable credit back to those originators and those creators?
Oh, credit back to the originators. All right. Of course, if you whenever you import a service in the infrastructure, for instance, suppose that you import a model, you are the author of that model. Okay, and everything can see, and everything is stored. Also, if a user, if you decide to share that model with others, you maintain the credit and the attribution of such methods. And I hope this answers the question.
It does, thank
you. Yeah. Now a question, we just heard about Galaxy, now we see about D4Science, and there are different theories. Can you say something about maybe difference or connection? Or?
So Galaxy will be, and is actually being integrated as a further, and enlarging the service offering for the VREs. So very soon in Blue Cloud 26, but already in Fairies, we're trying to, we are working for making it as a further tool available within virtual labs, just as like Jupyter or RStudio. So that is, and more on that, maybe. With respect to the tools that Marie-José has presented before, what we are trying also to achieve is to allow, to import your model in the VRE and to make it available as a tool within our Galaxy workflow. Yeah, that's what we are aiming at.
Thank you very much.
Okay, so next speaker is Paolo Di Viaco about Fleets Plus Virtual Playground.
Thank you. Supposed to, I checked it before, supposed to work. Yeah, coming. Takes a while, but we can manage it. Maybe. Okay. Yeah. Okay. So, my name is Paolo Di Viaco, and together with Alessandro Busato from OGS, we tried to extend a little bit the, to extend a little bit the concept of the virtual research environment. And we've been lucky to be funded by the Eurofleets Plus project. So the Eurofleets, there have been already presentation yesterday about the Eurofleet projects, so I won't spend too much time on that, but essentially as a very important project that allows to access to, let's say, vessels, marine infrastructure in general, and at the same time also invests in the development of new software and new method, new ideas. So in this perspective, we had the chance to work on an extension of the concept of the VRE, or the virtual research environment, that with some humor we played. We called the playground. So let's start from some definitions. So from Wikipedia, virtual research environment is a system that helps researchers to collaborate. So I highlight this term because it's quite important, because there is a traditional difference between collaboration and cooperation. And collaboration happens when people have aims together to a shared goal, while cooperation can have individual goals, okay? And what is a shared goal? A shared goal is something that allows you to override the differences among the people, among communities. So we start from the I to the we. But to do this, especially in the scientific research, we need to consider several problems. The scientific method actually is a loop between induction and deduction. So there is a generalization, then we grow up somehow an idea, a theory, then we try to predict a case and observe if it's the case, okay? But the observation is pretty interesting stuff. It's not so easy to handle. There's a giant literature on this that shows that experiment is not a simple observation. Actually, it's a projection also of what someone hopes or thinks. So also the motivations, the social context can be important. So let's start, we move from logic to something more social logic. And also here there are some interesting terms that can be used. A paradigm is, for example, kind of, let's say, something that a community share. So tradition, beliefs, myths, okay? And the interesting thing is that, let's say in modern epistemology, Kuhn, for example, said that different paradigms to try to be incommensurable. So they cannot understand each other. They try to separate, just like a speciation. You know, that you have squirrel on one side of a canyon and the other are completely different. So let's say the more contemporary epistemology try to describe community as tribes. Okay, we need to somehow try to override this example. So we have great example of VRE. We have heard about well, the galaxy and different science before. Great example of VRE, very useful. Nothing, of course, to complain about it. But just wanted to point the fact that probably there is something that can be added to this, okay? Because essentially what we get, for example, using Swarm with virtual research environment or Copernicus, is some storage, way of computing, and maybe, and this is, I think, is very interesting, a catalog of curated Python scripts or scripts in general. And for example, I've seen in the Galaxy the possibility to have a visual representation of modules that represent a workflow. This is very, very interesting. But so essentially we have data, we have computing power, we have scripting. So we share the data, we share the workflow, but actually we do not address the problem of, let's say, meaning, to try to understand exactly what's going on. So the assumption, the initial assumption is that researchers know what they're doing, how things have to be done. And for example, this can be used, for example, to address someone new coming into the team. It's not so easy sometimes to transmit the knowledge. There's also something that is called tacit knowledge that cannot be transmitted to someone else, that just remain the practices, okay? So does VRE, the current implementations, very good implementation, of course we don't, we have nothing against this. But we think that they do not actually address the collaboration itself. Maybe the possibility to use the data online, to use large computers and whatever. But we humbly think they do not address collaboration, so because they do not enter into meaning, okay? Paradigm remains separate and they are not overridden. So the current VRE implementation do not aim at collaboration, but they provide shared space where people can run workflows or processes. There is another, let's say, traditional also graph that distinguishes data, information, knowledge, and mirrors this into syntax, semantics, and pragmatics. Pragmatics, in my opinion, is the way to go, but it's kind of complicated stuff. It's not. It's a little bit fuzzy. So I think semantics maybe could be an interesting layer to use in the perspective of pragmatics. So what do we have? We have controlled vocabularies. We have, I think, the best experts in the world of semantics in this room. We have ontologies. Can we use maybe ontologies to map our knowledge and try to transmit it to the other member of the team? So the idea is to use ontology. Ontologies can describe very complex objects, such as, for example, the pizza. The classical pizza example, lesson 1, part 1, and use it as a map. You know, and this is an interesting quotation I've found from Suchman in 87 that describe a map as a formal construct that can, but not necessarily controls activities. It's just like a traveler's map, you know, does not control the traveler's movement through the world, but rather describe how to do something. And you can choose one or the other. It's a way of actually knowing where you are and how to get somewhere else. And that could be very useful many times, even for for yourself. I mean, so we can have very convoluted, complex ontologies, for example, in this case of plastic at sea, or a very simple one. Depends on the detail you want to use. And here we come to the actual, so lots of a long introduction to actually the core of the thing. So what can we add to what is already available as a virtual research environment? Well, we can add this mapping of knowledge and a way of collaborating, say messaging, sharing the data through messages to the other members of the team. But the map of this, of the activities, I think is very important, can be done using ontology because it introduces many other interesting possibilities. So what we have done, we have used, say, a software we are developing in a while. It's quite some years that we are working on that. Right now, we do not have means to produce ontology inside our software, so we use Protégé, of course. We design an ontology, and we upload it on the web into our software, which is called Colla, because in Italian, colla means glue, so it keeps together the researchers. So you just visualize the ontology as nodes. Each of these nodes become a container of information. For example, here you see that in the visualization, the node generates automatically links to computing facilities, to the essentially some kind of, I will show you later, a Jupyter notebook, to the data, and to the messaging facility. The messaging facility we have incorporated is pretty complex and can handle pretty complex messages trees. And the interesting thing is also you receive, of course, all the emails in your mailer. We have a file manager, but this is still something, say, standard as it's in already existent VRE. You can have preview and things, and of course, you can have the computing. We are a little bit snobbish, so we don't use Jupyter, we use Zeppelin, but it's just a matter of, okay, choice. In our framework is easier. And within the Eurofleet project, we tried to focus on our background, which is seismic data, exploration seismic, not seismology. So we developed, let's say, an interpreter inside Zeppelin to use Seismic Unix, which is a standard software which is used within the exploration seismic community to process data. So we have this front map that allows us to know where we are. Then we enter the node and we find there all the information that are aggregated and makes sense within one of those nodes. We can then access the messaging, the messaging, the computing facility, and so on and so forth. We have, of course, several limitations. We hope this will be just a stimuli for the future work. We need somehow at the beginning of the project a facilitator that organizes the work. This can be something not easy to handle. The ontology now is built outside the virtual playground, so one of our dreams would be to have it inside. Nodes at the moment can be shared across tasks. There's still something that have to be let's say, further advanced. And one of the main problems we found, especially in our case for seismic data, is the interactivity, the visual interactivity, because there are several phases of the processing of data that need actual interactivity that is not allowed by the Jupyter Notebook or the notebook in general. Thank you, I finished. Of course, we have done already some publication. If you want me to explain, of course, I'm here. Thank you.
Thank you very much, Paolo. Unfortunately, we will not have the time to take any questions, but I refer you to Paolo in the lunch break. Please have lunch together with him. And
well,
sorry for that.
We have to provide a lunch table.
Thank you. Since it's lunch soon, we have to move on to our next speaker, which is Adrien. There you are, from NERSC, presenting another virtual lab for the Arctic this time. Welcome. You know how this works?
No.
Okay. So in this folder, you have to find your. In this folder, you have to find your stuff.
All right. Thank you. So hi everyone, my name is Adrien. I work at NERSC as a software developer, and today I will talk to you about Narval, which is a fairly recent project. So first I will tell you what it is, then what it's made of, and what it can be used for. So what is Narval? Narval is a web visualization portal for Earth observation data and model data. It is centered on the Arctic and allows you to display and overlay a number of data products. It's updated daily for these products with a 1 month retention and 10 days of forecast. The main goal, main interest of this tool is data discovery. It is well suited for qualitative analysis to explore the huge amounts of data that we can get today from satellites, in situ, etc. It can also, of course, be used for dissemination and education. The components of Narval are so first a processing chain to get the data, and then the interface, nice interface to display it. So all of these components are open source. The processing chain is based on Geospace, which is Python software developed at NERSC, which takes care of cataloging and processing the data. So it takes care of harvesting all the metadata we need from various providers, like NASA, ESA, etc. Allows us to search by time and location and to convert it to the proper format so that we can display it in the interface. The interface is SynTool. It's developed at Ocean Data Lab. I'm sure a lot of you are familiar with their work. It's the interface used for Ocean Virtual Laboratory, for example. Yeah, so that's it for the components. All of this runs on the NERSC infrastructure on the Kubernetes cluster in containers. So I'm going to show quickly the functionalities of the interface. So you can display some raster data. So here, these are models. Then you can overlay, for example, satellite imagery. That's Sentinel-3. You can display vector data as streamlines, in that case, current. Then you can play with transparency between the layers. You can also attach images to the data sets that you display, which allows us, for example, to display Argo float profiles. And that's it for the very short overview of the interface functionalities. Then I'm going to talk about the use cases. What can you do with this interface? So first, very standard use case, we overlay some models and observations. In that case, NextSim and the NextSim CS concentration. That's a model that's developed at NERSC. Sentinel-1 SAR data, and Topaz sea surface temperature and current. So this just shows you can display a lot of data from multiple sources. Then we can have more specific use cases, like for example, this was used in a project called S23D EDDI, the subject was the study of eddies in the Lofoten basin off the coast of Norway. And here we can see very nicely mesoscale variability and multi-sensor synergy. You can see the same feature present in both Sentinel-1 SAR data and Sentinel-3 chlorophyll data. Next, we can also explore new data. So this is the example of the SWOT mission this data became available fairly recently. What we see here is the fast sampling phase, which happened in the 91st days when the data was available. This is a one-day orbit, and they then evolved and moved on to a 21-day orbit for maximum coverage, which is what we see here. This, by the way, is the sea surface height anomaly. SWOT is an altimetry mission, and here we show 2 weeks of data coverage. For this kind of mission, it's very important to be able to collocate it with in situ observations. So here we can see, for example, that we can collocate Argo profiles with this sea surface height anomaly from SWOT. So all the little blue dots are places where we have Argo profiles available, and the red squiggly lines are the Argo profile trajectories. So this showcases quite nicely the ability of the portal to display large-scale views while also allowing you to zoom in to mesoscale features and also to a limited extent to work with three-dimensional data. Please note that the Argo profiles are generated in advance. This is not dynamically generated for performance reasons. Then we can also collocate observations with models. Once again, this is generated in advance, but we can see comparison between the Argo float and the Topaz 5 model. Topaz 5 is a model developed at NERSC as well. And finally, we can also use it for more high-resolution models. For example, this is NORSCHUST 800, which is produced by the Meteorological Institute of Norway and used for forecasting Norwegian waters, for simulation of oil spills, parasites that can affect fish farms, etc. So we have a wide variety of applications for this portal. Okay. So finally, Naval is a web visualization portal for Earth data. It's already publicly available at the URL that you can see here, naval.ners.no. It allows you to take advantage of multi-sensor synergy and collocate data from multiple sources. There are already several products available, updated daily with a 1-month retention window, plus 10 days for forecasts, which is for storage reasons. It can be used for interface as an interface to showcase projects, or in the context of digital twins as well. And was funded by the Research Council of Norway as part of the Nansen Center basic funding and ESA's ArcTALAS project. And that's it for me. Thank you.
Thank you very much, Adrian. We have 4 minutes until lunch, so we're happy to take any questions that you might have. Say once more what kind of data is in there already. You said there are a lot of data available already.
Yes.
So the noise you have the noise 800 in there.
We have the noise as a sample. It's not updated daily yet. For the daily updated data, we have Sentinel-1 SAR, the NextSim model, few variables from the Topaz model, Argo floats profiles, just not by Argo yet, but it's coming. Working on the SWOT data as well. And I'm sure I'm forgetting. Yeah, we have some CIS data from Aviso as well. Pretty sure I'm forgetting some, but yeah, that's about it for now.
Yeah. Thank you very much.
Thank you.
I think then it's Helge's turn again to say one word, but before a warm applause to all the speakers so far before we go to lunch.
So, it's lunch. I have to vary a bit. Be back at 2 o'clock and try to finish eating by 1:30-ish, so you satisfy the guys at the kitchen. Hello, everyone. I see you are back, most of you. Very good. Are we ready? Christine, floor is yours.
Okay. So the next presentation is Marine Vernet, who will speak about the modernized CSR directory.
Okay. Nice afternoon to all. I hope you had a nice lunch break. Today I will present you or give you a short overview of the cruise summary report directory as it is now and future actions. So very briefly, I work at IFREMER. I've taken over the management of the cruise summary report directory that is part of the C.NET infrastructure. So I've taken over these activities last fall from Vanessa Tosello, who was working before and coordinating the development of this service during the C.NET Cloud project and after the project ended, since it has been uptaken by IFREMER from BSH Germany in 2019. So I'm working with Nolwenn Dagnew and Fred Mercer for the curation and technical creation of CSR entries and technical developments, and with Stephen Peel in link with the C.NET infrastructure because he's piloting these activities for IFREMER. So, as I said, the cruise summary report directory is part of the C.NET European infrastructure for marine and ocean data management. So first thing is, what is a cruise summary report? So CSR are a usual means to report on cruises and field experiments at sea. They provide a first inventory of measurements and samples collected at sea with different kind of information about where the cruise was conducted, when, by who, what has been measured, and how. Currently, the cruise summary report directory covers cruises from 1973 until now, from more than 1,600 research vessels. And in total, the CSR directory preserve and give access to more than 68,000 cruises in all European waters, but also global oceans. So the CSR workflow is quite simple, in fact. The chief scientist or the NODC data manager in charge of who have the information on the cruises can connect to the online back office interface to create and update their CSR by either completing online forms or submitting XML files. So after submitting their files, the CSR entries are validated by an administrator at IFREMER. And once validated, those CSR entries are published on the CSR search interface. So the CSR back-office interface makes use of the Marine ID service. It's an authentication service developed by IFREMER. Once connected, you have access to all the CSR entries that are attached to your account. You can choose to either create CSR entries using online form or import several CSR XML files formatted to use the CSR C.NET ISO 19139 format that you can produce. So those XML files can be can be produced using the C.NET Mikado software, or you can produce it by your own means also. And you have the possibility to either duplicate or edit existing CSR entries or submit updates to existing ones. So the back-office interface then performs duplicate checks and controls with existing CSR in the database. And once you've passed those controls, you can then preview your CSR entry or entries in order to do a final check and choose to submit either some of them or all of them for validation. And then there is interaction with the validation team at IFREMER. And once validated, those CSR will be published in the CSR search interface. So the CSR search interface allows you to search for cruises using free text search or text search in controlled lists. For example, you can search by EDMO code for organization, but you can also use filter facets such as date, country, platform, data type, or discipline. And you can also use geographical search facets by either selecting a predefined area that is linked to the marine regions area, or by selecting the area of interest on the map. So these search functionalities can be combined in order to easily find the cruise you are looking for. The CSR interface also allows you to export metadata in XML or CSV formats. So this is what a CSR entry looks like on the CSR search interface. Here's the Rosos cruise. So you have general information about the cruise, such as the identifier, temporal information, the information about the chief scientist and responsible laboratory. You also have a short description of the cruise, information about its location, so it can be either bounding boxes, ocean areas, or marathon squares, and also a track of the cruise. And you also have additional information that you can fill in to give information about, for example, the instruments that were used, the parameters that were measured, the projects in link with the cruise, our station lists, and submit a summary of measurements. And the important part is that you can also access the data that are linked to this cruise. So there is a button near the title of the cruise. And if you push it, you will access to the C.NET CDI catalog. That is if the data publisher has included the CSR reference in its CDI. So such references can also be made in the EMONET ingestion interface, such as CC mentioned this morning during the first phase of the submission. The CSR directory is a kind of interoperable system. The CSR metadata format is based on the ISO 19139 Inspire compliance standard. The metadata content makes use of several C.NET common vocabularies that are exposed fairly on the NERC vocabulary server and also on the C.NET website, as well as references to other directories such as the IDMO directories for organization or EDMEP directory for research projects. And the CSR content is also exposed in RDF through a SPERCUL endpoint to facilitate machine-to-machine interactions. So this is what the CSR architecture, technical architecture look like. So CSR metadata are stored in an Oracle database. The CSR back-office interface populates this Oracle database, and metadata are exported and synchronized in an Elasticsearch index using a Java badge. The CSR front office query the Elasticsearch index using a REST API, and the back office and front office share a set of functionalities such as search mask or facets using an Angular library. Here we can see its graphic that represents the number of CSR that have been put in the CSR database starting 2012 until March 2024. We can see that the CSR directory, even after the end of the CData Cloud project, that is in 2021, it's a gray part on the graphic, continues to be used and populated by users. We had 3,567 new CSR entries and 1,049 updates in 2023, and 43 new users also. So this proves that there is an interest of the community in the CSR directories, because it provides a way to preserve and share oceanographic cruises information, and a way to give access to the associated data through CDataNet infrastructure. It also fosters reuse of data by providing useful context information about the data provenance. And the CSR has indeed served different initiatives such as Eurofleet, ARISE, and POGO. And this CSR database can also provide analysis material. For example, last year there was a study conducted by the French Oceanographic Fleet Research Infrastructure, and they make use of the CSR database, the CSR data, in order to create maps of oceanographic cruises per Mazen square. And the idea was to identify common areas explored by different fleet operators, and also in explored areas as well. So what's next? We have several ideas of improvement of this service, but such as, for example, facilitate the use of the back office to fit the different uses, propose different kind of right management for IMDIS, for example, improve the geographical search and propose statistics per country or collate center. But to help us prioritize and identify possible improvements, we will conduct a survey during 2024 to collect users' needs and point of view. And if you are a CSR user, you will receive this form in the future weeks. And we truly encourage you to respond to it honestly. And yeah, and what's more, when we will explore connection with existing and future initiatives such as marine facility planning, for example, or a cruise project, or perhaps a future fleet research infrastructure as well. So thank you for your attention, and I can take a question if you want.
Thank you very much, Marine. There you go.
Thank you for your presentation. Obvious question from my side, linked open data publication? And the planning, question mark?
Could be. It's not yet in planning, but...
I'd like to be involved.
Okay, I have a contact then.
You were referring to a back office. Are these the people who put the data in, so from the cruises? Or how did you get this buy-in so that people actually give you the data from the cruises and put it in?
Oh, it's not data we're talking about, it's metadata. It's cruises information. And this is centralized, or it depends on the country, but could be centralized by the National Oceanographic Data Center. It's also an heritage of the CDataNet projects, where there were kind of community putting data in the CSR, I think, and it's still going on even after the project, because there is a use to it, especially if you're submitting data to the CDataNet infrastructure.
Okay. Thank you very much.
You're welcome.
If no more further question, then I thank you again, Marine, and we move on to the next speaker, which is Asuka, talking about optimizing data discovery and preservation. Ah, there you are. Floor is yours.
Yes. Good afternoon. My name is Asuka Yamakawa. I am a data manager at the Institute of Marine Research. Today, I want to present optimizing data discovery and preservation for Norwegian data. The history of Institute of Marine Research, IMR, is pretty old. It started 1900. It was established as a center of oceanographic research in Norway to conduct research on marine resource, marine environment, and aquaculture. 2 years later, ICES was established to coordinate and plan the work of oceanographic data collection with an interest of Northeast Atlantic. 1961, IODE of IOC of UNESCO was established. It aimed at encouraging the international exchange of oceanographic data and to support capacity transfer from developed country to less developed country. And 1971, Norwegian Marine Data Center was established in IMR, and NMD became IODE, National Oceanographic Center. The responsibility of NMD is a long-term preservation of all data collected and generated by IMR. 2017, NMD received Core Trust Seal certification the first time, and it was renewed 2021. And last year, NMD received IODE NODC accreditation. We are responsible for marine data in Norwegian waters. We have about 2 petabyte historical data since the establishment in 1900. And this data include diverse formats, standard, media. Also, some data are non-digital format. In addition to the historical data, we receive near real-time data every day from mooring, CTD, glider, and ferry box. And we generate 250 gigabyte data every year. We are engaged digital transformation for IMR data to increase the efficiency, variety, and quality of products and services that generate value to our stakeholders. By Danish National Forum for Research Data Management, from a fair perspective, metadata are more important than the data because metadata would always be openly available, and they link research data and publications on the internet of fair data and services. That's why the fair principle is priority for our data strategy. As I mentioned, we have 2 petabyte or heterological historical data. It's a pretty big challenge for us. The adoption of standard for metadata collection is necessary for the succeeding in rescue and preservation initiative by HILS. That's why we implement metadata rescue program. It developed mechanisms to migrate historical metadata into standard format and digital infrastructure that ensures all generated data is scalable. It includes a retrieval of metadata from our historical data and convert it to community-agreed standard like ISO 19115. In this spring, we implemented the first metadata rescue program, and about 2,000 records were rescued. We established NMD metadata management system to preserve, collect, distribute, store, and processing the data. We design the architect with scalable. We design it as a scalable with a scalability, and focusing on these 4 points. It should ensure linkage of different subsystems, maintaining consistent metadata, and it has to allow synchronous processing and reducing dependency between subsystems, because we need to use this system on board. In addition, it makes us easily maintain and extend. Also, to save the development time and cost, we leverage on existing open source infrastructure as much as possible. And it is necessary to comply with community-adapted best practice and standard. So this NMD metadata management system is a center for our metadata integration and dissemination. This is the architecture for our NMD MMS. Before the cruise, data manager creates a cruise plan, and data are stored into an NMD cruise database using cruise data user interface and API. And during cruise loggers are automatically created and managed by cruise logger user interface and API. The last summer, we have developed cruise geotagger system. The ingestion module take both NMD cruise plan data and cruise logger data and tag the data for each record. And we have also developed metadata gateway system. The first module ingests both cruise data and geotagger data, and join, and these data are populated into ISO 19115 database. And extraction module makes XML ISO 19139. Then open source GeoNetwork ingest XML ISO 19139 and publish the data. Also, NMD ingests the XML ISO 19139 and publish the data on the NMDC or future NMDS. NMDC is a data portal managed by NMD. Yesterday, Helge presented about NMDC. The cruise geotagger set semantic keyword and geo-area keyword. For semantic keyword, we used 4 standard vocabulary, 3 vocabularies from CDataNet and DCMD keyword. And for geo-area keyword, we employ 2 standards. And in the metadata gateway system, the cruise plan and cruise geotagger data are ingested and joined. And in the system, data are converted to ISO 19115. And we have designed the ISO database with scalable and extensive architecture, so it is easily adapted the improvement of ISO standard. Also, it's possible to extend for our need. And here we use version 3. This is the latest version. The latest version accepts multiple languages. That's why our system have a translation functionality inside the system. At the moment, we translate the metadata into 6 languages: English, Norwegian, French, Arabic, Spanish, and Portuguese. this is my last slide. This is future work. NMD metadata management system is cornerstone to improve the publication of near real-time data and historical data, complying with the FAIR principle and linking up with external data system. Artificial intelligence will support the future process of automated curation of metadata content. NMD MES will become a key component for collecting and distributing the metadata of the future NMDS toward Ocean Info Hub, and it will also support capacity development in metadata management with NODC and associated data units from IOD networks. Thank you very much.
Any questions? I have a general one, and that is this. You said you translated the metadata into these 6 languages.
Yeah.
My question would be why, and why these 6?
Because first for us, we need English, and we are Norwegian. And also, we are working on the Norwegian data, but also we are working with FAO data. They work with a lot of African countries. That's why they use a lot of this type of trans.
Okay, thank you. Understood. German was not in the list. Yes, exactly. If there is no further question, Christian is already getting ready and is taking over right away to talk about us about the good practices, the federated system for that. Welcome, Christian, and thank you again.
Presentation mode for PDFs was down, right?
Secret.
Ah.
Secret. Here, this guy.
Okay, I was suspecting that, but not really. But thank you, Ute. Well, thank you very much. I'm so glad and happy, and it's a great honor to me to be able to present this today, which is an initiative that started already to be envisioned a few years ago, 2021, but 1.5 years ago, on synergies with the creation of Ocean Info Hub and so on, we really pushed that forward. And it's with all the top partners here that have been really promoting this, together with UNESCO IOD, with the Ocean Best Practices System, but also with FAO and ICES. Of course, it's far more than this. Behind that, there are many programs, many organizations. Most of them are here already that have been supporting directly or indirectly this roadmap. So, said that, yesterday I was just planning a bit or playing a bit with ChatGPT. I must admit that I'm quite addicted since the last 2 months with this tool. And I was just querying about, give me best practices related with salinity measurement on the Baltic Sea. And then it came back to me with this. Of course, I'm extremely using OBPS all the time, so the model is quite biased towards my preferences. With Charles, for example, he's not a user because we tried that in his computer yesterday and it gave nothing back. But nonetheless, still, this query is something simple. It's not what we really want. I mean, this is a bit more like Google, a bit more vitaminated, right? It's giving back some links that are providing the access to the methods or practices into the, in this case, in OBPS, with a bit of verbosity. But the real queries that we want to do here is hey, it's like in Star Trek, right? That they were in that voyage in the space, and it was all the time like, computer, I have a problem, just solve it for me. Give me answers, give me what to do. So this is kind of what we would like to do. Hey, ChatGPT or whoever, I want to measure this somewhere and I have these resources, can you give me recommendations? Can you? So at the end of the day, you don't even want to read the document, so to speak, as a lazy user, right? We are now accessing the documents because it's what we have, but in a few years' time, what we envision is that the machine can give us results, we can query back, and it's refining the content of the methods and giving us the responses that we need. Today we were talking about different things, about the digital twins and how this is, for example, in terms of how we can use in these workflows connecting tools and services that could be eventually connected to machine actionable methodologies. Or we've been talking about training of MLNet modules, for example, that at the moment, yes, we are accessing the document from MLNet, but for training purposes, you could interact perfectly with these interfaces and regarding the problems that you are having, that the machine is just clarifying for you the doubts that you have, because maybe in the document itself, it's not yet clarified enough. Or, yeah, for example, most importantly, about the beacon thing with Peter and subsetting about communities, data, etc. Instead of subsetting by communities, you could say, give me all the temperature data that has been collecting according to this methodology, or whatever, because everything is kind of connected. But before reaching that point, there is some groundwork to do, right? But at the end of the day, as a user, you just want a single point of discovery to really relevant content or know-how, because it's what methodology is about, is the know-how, tell me how to do things. That, of course, is supported by, it's reliable, there is quality behind. So these are three main elements. There might be more, but to me at least they are the most important to keep in mind. So this is kind of what OPFN it is. Before having all this layer of complexity in it, we still work with documents, we still work with repositories, and before feeding all these models, what we need is really a lot of content. We have the firepower, but we need ammunition. We need more documents, more data connected and interoperable when it comes to sharing methods and documents. So the Ocean Practices Federated Network, this logo, by the way, is generated as well by ChatGPT. That's what it thinks that I would feel about having a logo for that. But this is planning to be a global network connecting isolated or fragmented repositories that may enable, and that's important, centralized discovery but distributed access to relevant and reliable documents, reliable. We will come back to this later. So once we established this, definitely this will provide enhanced discovery opportunities whilst preserving autonomy and control by the provider. So we are not trying with this to deviate the traffic to the users as we were doing up to now, for example, with OBPS, where we were using the last years to collect a lot of documents into one central repository. But then, for example, at the end of the day, the traffic of the users were going to one repository itself, and the creators of the documents were not kind of being credited on the long term, right? So with this, we want to really avoid this part. This will improve deeply interoperability, hopefully also from the user perspective, that can really ensure that. At the same time, that is using the interoperability layer behind from IMDIS architecture. And at the end of the day, this is the part of the technology, but technology merely would reach half part of the way. We really need the community engagement. We need the soul of that. And this is what this would be about. There is a need also for OPFN to be a platform for community engagement, for allowing cross-validation, for allowing the practices to converge into best practices, to harmonize ways that we are doing things when necessary, of course. So on the right side, or that side, all used traditional way of accessing documents, right? We have the different repositories, the users accessing the information individually. Some of the information are replicated in some repositories. Some are present in one repository but not in the other, et cetera, et cetera. So that's the always recursive things. Users want a central point of access. So what we propose is all this orange stuff where we have one user interface with this central discovery and distributed access back to the repositories. And for that, we are planning to use Ocean Info Hub, so everybody adopts, everybody connecting to the network adopts the pattern for methodologies. It's submitted in Ocean Info Hub, and it's the network who filters the content in Ocean Info Hub related with the practices. And it's in the user interface on the this OPFN EDS enhanced discovery search that we would then implement advanced searchability to provide relevant outcomes from the search. So first initial nodes in these initiatives is FAO through OpenAFSA, sorry for the ISIS library, and the Ocean Best Practices repository. So they are three main sustained and mature infrastructures that are now able to connect. Already FAO and Ocean Best Practices system has implemented the pattern for Ocean Info Hub, and hopefully ISIS will be soon as well on the train. But all the benefits come with challenges, of course, and in terms of sustaining the network that we are about to create, in terms of ensuring that the content is robustly shared, we need some kind of guidance agreement. So we expect that the different nodes joining the network can participate, or I encourage or should be obliged to participate in structuring minimum governance on how we are going to behave in this new community. Interoperability layer is important because everybody is managing their own vocabularies, and what we really want is to provide relevant search results. So there will be a lot of work on here on how to mapping cross-domain vocabularies, on what find solutions to really improve this searchability. And then quality assurance of the content. We need to ensure that the content that is being shared, and the metadata that is being shared, is complying in minimum requirements for completeness, for validity, for consistency, right? So apart from that, there are many things that are happening in Europe, for example, right now, and there's a need for integration as well. And just for citing two, right now, this is the European Union Aquaculture Assistance Mechanism. You have the screenshot there. They are compiling basically methods and best practices related only with the aquaculture sector. The other one is the European Commission Ocean Best Practices and Standards System that is right now on the way of being produced, but at the end of the day will contain those methodologies, best practices and standards that the European Commission would be ready to endorse to be widely used in Europe. So the question here is how this network will interact with these end users, whether this could be also nodes into the network. So there's a lot of groundwork to do here in the future. Now, allow me to say that this really turns my engines on. So this is, after 8 years, a really good result on, at least to me, sorry, on how OBPS has been leveraging with existing infrastructures in Europe. And IMODNET is a very good case of that. 9 months ago, maybe they can correct me on that, but already IMODNET chemistry and bathymetry started the journey of implementing the link between data and methods. And right now, IMODNET physics has started to work this way as well. And this is an example in particular from IMODNET physics, where the ERDAP repository is linked to the Ocean Best Practices repository. And you can see in the red lines how the data is linked back to the method in the repository of OBPS, whilst there is also the URLs to the data back to ERDAP. This is really good because this will really allow the machine-to-machine connection when you start asking, filter me this data that has been collected using this methodology, et cetera, et cetera. So to me, it's a really important step forward. 1 minute, okay, then. We've been discussing a lot on quality, and we've been strongly criticized for that, sometimes constructively, sometimes less, but with the reason, because the word best practice has been overused during the last years, and in some terms even misused. So there's been a lot of controversy on, okay, what is really qualified to be a best practice, how we can guarantee that third element that we were discussing on guaranteeing the quality of what we are saying this is a best practice. So the authors that you see here has proposed, this is now on the process of peer review, and has proposed on this scale of 5 levels based on capability maturity models, where the important aspect is to try to objectivize in a quantitative way what can be qualified a good practice, better practice, or best practice. There are different communities that have been already trying this. ISIS is right now testing that as well, and hopefully there will be some feedback. So we expect that this could be also a good example to move forward with the federated network. We don't know, but it's a proposal for guaranteeing about the quality. Then automating metadata curation and improving searchability. We've been doing a proof of concept on that, but I'm not jumping into this now because it's too late. But basically, just to summarize, the OPFN is emerging as a shared effort guided now by UNESCO, IOC, FAO, and ISIS, Angus, sorry. Although there is a huge community that has been already supporting this, and that's important to mention. We will provide central discovery and distributed access to methods, best practices, and standards, relying on all this architecture for interoperability layer, and we have plenty of future work to do towards that vision that we were commenting in the beginning of, hey, Google, do that for me, give me the answer, I'm lazy. So, yeah, I think that probably can stop here just in case there's any question or something. Thank you.
Thank you, very nice, inspiring presentation. I noticed that you said showing the connection between the data and the methodology applying to it. And of course, I know the ocean best practices from Iliad also, but what it made me think of is the Geo Knowledge Hub, which is exactly about that, to show the data and the pathway until a result. Have you considered working with them, or are you familiar with the Geo Knowledge Hub?
Say again, please, the Geo...
Knowledge Hub, so the Group on Earth Observations Knowledge Hub.
In particular, myself, I'm not acquainted, but I'm sure that some people in our group may have been already thinking on that. I would quite bet on that, but it's not been my main activity in tailoring this, so I unfortunately cannot say, but I'll keep it in mind and query to my colleagues back.
Wasn't Pauline on the author list? Yes. Wasn't Paul? Yeah. And they are in the Geo, aren't they?
Then I can gladly say, yes, we are aware on that.
Okay, yes, thanks for an interesting talk. I was just wondering, considering, I mean, you talk about best practice, and that seems like a end point for a method. But we all know that methods develop over time. How will this work with, especially when you loop around back to the geodata coming out of different practices, different methodologies?
Why you had to ask this? I'm glad that you asked that. It is really a controversial thing because, you know, the initial explanation or definition of best practice is, okay, it's a methodology that has shown better results than other methodologies with the same objectives, and to be elevated to a best practice, this method needs to be adopted by multiple organizations. But this definition, okay, there is more on that, because this showing better results than others is really, really conditioned to context and situations. So you cannot ask to measure with a certain degree of accuracy a particular variable here in Norway or in Ghana. Definitely. So this context needs to be clear, so that the definition best practice at some point becomes, it needs to be flexible when it comes to application. It's not that, okay, we are converging all the time to one single best practice for this particular domain, because really it can depend. So that, in my opinion at least, and it's only my opinion, there can be other ones, definitely we need to keep this flexible, because one single methodology can be adapted or used in different contexts. But I'm not sure if I responded to your question.
It's also the temporal thing. Whatever best practice changes over time.
Yeah, that's also a good thing. That's why what we were trying before with OBPS, well, we've been trying that, and we want to move forward with this into the federated network, is this community engagement part. As I mentioned, I've talked a lot about the technology, because this is what it's about mainly this, this meeting. But the community engagement there is important, and we in particular are not the ones to decide on this because we are not the domain experts. We facilitate the context for magic to happen. So what is really important here is that different communities join together there and they put the rules on precisely that, how we as domain experts decide that the evolution of this method becomes or not a best practice, or it was a best practice from the 80s till the 90s, and then now, did I respond better now? Yeah, okay, that's it's a tricky question.
Okay, thank you, Christian. So now we move on to the next presentation from Com Walsh about building a system to make it easier to find marine data.
Just a moment. There we go. Brilliant. Okay. Thank you very much, Christine, for the introduction. So, good afternoon, everyone. So, my name is Colin Walsh from the Marine Environmental Data and Information Network, also known as MEDIN. And today I'll be talking to you about how MEDIN have built on an interoperable federated system to make it easier to find marine data. So just for a quick bit of context, I'll just need to explain a little bit about MEDIN. So we are a long-term open partnership of marine organizations committed to improving access to marine science data. We're funded and governed by a consortium of sponsors who lead the UK in marine data management, and all of our sponsors are represented here at the bottom of the slide. And MEDIN's overall vision is, of course, for all UK marine data to be fair. And one of our key objectives is to support the UK marine sector to implement global and cross-domain interoperable marine data services. And because, as we all know, marine data are quite expensive to produce, and they're also a unique snapshot of a time and a place. So our ethos is to measure once, use many times. So yeah, essentially we work with UK organizations to deliver data to the marine community, and these data sets are then fed directly into the MEDIN portal, which you can now see here on the slide. So this is hosted by MARIS, and it is a federated system that provides access to over 17,500 marine metadata data sets. And roughly 85% of these are actually provided directly by 7 MEDIN accredited data archive centers. All of their collections can be seen there on the far hand right. They can be accessed in blue there. And then the remaining 15% come directly from a mix of both public and private sector organizations. So there are over 600 different organizations in total that collect or manage marine data within our portal. So the portal then itself is underpinned by the MEDIN Discovery Metadata Standard, and the MEDIN standard itself is a marine profile of the UK Gemini standard, which in itself is a UK-specific profile of the EU Inspire directive, which of course is derived from ISO 19115, which is ISO's geographic information standard, and also ISO 19139, which is its XML implementation schema. So what makes the MEDIN standard marine specific is essentially the control vocabularies that we use. So for example, we both mandate or recommend multiple collections from the NERC vocabulary server, ICs, CDataNet, EPSG, just to name a few. Okay, so going on to our recent developments. So over the past year, we completed 2 developments in particular that enhanced the findability and interoperability of our marine data catalog. And of course, this subsequently boosted their accessibility and potential reuse value. And so yeah, the first of these was to make our catalog of metadata in our portal accessible using an API service. And the other was then to make our existing schema.org JSON-LD more interoperable and also to enrich it further by adding more properties to it. And this was mainly driven to expose our UK marine data holdings on Ocean Info Hub. So, starting with the API, one of our stakeholders needed to develop a custom digital solution that could both query and retrieve metadata from our catalog of dataset records. This was actually the Offshore Wind Evidence and Knowledge Hub, also known as OWECA. So this was an initiative that was funded by the Crown Estate. I believe Johnny Mitchell touched on it briefly yesterday in his talk. So seeing that the MEDIN portal itself, it runs off GeoNetwork software, so we simply decided to enable its existing CSW API functionality, and that is, of course, an acronym for Catalog Service of the Web. And of course, GeoNetwork CSW API is also compliant with the OGC CSW standard. So then, once this was actually enabled, it didn't take too much technical intervention itself to get the API working, but we did need that human aspect to, tweak and adjust it to make it function the way we actually want it to. So both the Crown Estate and their contractor kindly collaborated with MEDIN to test the API to make sure it all functioned correctly and was doing what we wanted it to. And then in return, they got the use of a nice new shiny OGC compliant API service that lets them retrieve metadata for the service that they were creating. And so, yeah, so that work was completed, and just last month we published our user guidance for anyone who's interested in calling on our API to query our data catalog service. So that can be accessed there by just clicking the API button there, and you can see all of the instructions pasted underneath. Okay, so the next enhancements brings us to Ocean Info Hub. We've talked about it extensively throughout this conference, so I won't go into too much detail about what it is, but just like MEDIN, Ocean Info Hub facilitates the discovery and interoperability of existing information systems across multiple sectors, such as the private and public sector. And as you've seen already, every day probably so far of this conference, this is the Ocean Info Hub data portal landing page, where all of these resources can be searched for and accessed. And because one of MEDIN's main objectives is to support the UK marine sector to implement global and cross-domain interoperable marine data services, we sought to partner with Ocean Info Hub to make our metadata searchable on their portal so we can reach a broader and more international user community. So Ocean Info Hub themselves, they publish their metadata resources using schema.org, the vocabulary, and JSON-LD as the markup. So one of the benefits then for MEDIN being an organization where a key objective of ours is to boost cross-domain interoperability is that sometimes you get lucky and you already have that infrastructure in place already to be compatible with other systems. So this was the case for us because we already had a basic JSON-LD schema.org mapping to some of the key MEDIN metadata elements so that we could publish on Google dataset search. But it was more of a basic mapping of core elements such as your title, abstract, keywords, temporal spatial coverage. But this was actually enough for us to actually get our 17,500 records on there with minimal-ish effort. So then with our recent development, we further enriched our JSON-LD so that we could describe our metadata better on their portal by adding additional metadata elements and also making some interoperability enhancements to our existing schema.org properties. So the additional properties we added were conditions of access, node identifiers, SD publisher, provider, and of course the all-important distribution, because everyone wants to be able to actually access the data that the record itself is actually describing, so that's the most fair addition of them all. Then we also made interoperability enhancements to the keywords property included in data catalog and also spatial coverage. So just to give you a quick example here of our keywords property. So this was originally a URL link, which was just the link to the NVS term itself. Not the most fair, but not exactly ideal. But now it actually specifies the term name, also well, it's maintained the URL, but also defines the collection URL and also the term code itself. And then moving on to spatial coverage. So initially it was just simply the bounding box information, but so we built on this to include the coordinate reference system information using additional property. And in this instance, including the CRS vocabulary, it also appears here on the metadata, just making that little bit more interoperable. And another thing I think is worth highlighting as well is that we also made our JSON LD format downloadable from each dataset landing page. So you can see here that it's hyperlinked there. So if anyone's interested in seeing how we've mapped from our ISO XML to JSON LD, feel free to have a look. And yeah, going back to Ocean Info Hub. So now, as you can see, Medin's metadata catalog is now live, and we are currently the biggest catalog of data sets on their portal at present. And if you use Ocean Info Hub spatial search feature and filter for Medin, you can see all of the spatial coverage of the data sets that all of our stakeholders have published. And if you look at the Northeast Atlantic in particular, it's quite comprehensively covered, so much so you can't even really see the UK, Ireland, and much of Western Europe on there. But yeah, so just to quickly summarize, exposing the metadata using the API and also being a contributor to Ocean Info Hub has increased our fairness and allowed us to reach a broader and more international audience who can now benefit from from Medin's Discovery Metadata Catalog, and then subsequently supports our ethos, measure once, use many times. And of course, seeing I've got a few seconds left, for anyone who's interested, please check us out on our website and on Ocean Info Hub, and our newsletter, Marine Data News, and follow us on social media. Thank you all very much for your time.
Thank you so much. Perfect timing as well. Questions?
Hi, very nice. Line up with what we're doing in ILIAD, also extending the metadata. And I wonder if you extended the examples like spatial coverage, are you contributing back to schema.org or anything that can be reused by others, like your LD context for this extended?
Sorry, could you repeat the question?
Yeah, if you're extending the elements, like definition of the spatial coverage,
yeah,
are you contributing back to the schema.org or somewhere else that everybody can use the same frames in the same way?
Not at the moment. In fact, I took it wasn't actually we didn't conceive that. ESIP have some very nice best practice mappings and advice for schema.org. So if you are doing it, I'd highly recommend it. So they seem to be doing some nice, I wouldn't say, well, kind of standardization. So we looked at that, and also in the Ocean Info Hub team itself, one of the group is quite prominent with ESIP, and he advised on many of our mappings as well. I should also note as well that Ocean Info Hub have a resource called The Book, where they also provide advice on how to best map to schema.org elements as well.
Thank you. No, I was just curious because you mentioned the API from GeoNetwork, that you had some issues to kind of tune it.
Yeah.
Yeah, we're having the same problem here at AMR. My colleague Aska just presented that, and it's the last part of this pipeline that we have now where we are struggling a bit. So this is more a call for help, probably. So it would be a pleasure to perhaps meet you and talk later. Aside from that, I was just wondering the endpoint that you provide for the downloading the JSON LD.
Yes.
Is it directly linked to the SparkQL endpoints in Ocean Info Hub, or it's or you have already the files?
So they harvested from our sitemap.
Okay.
So they just draw it all in from there.
Okay.
I don't know the ins and outs of how their system does all its indexing on Otis, but that's essentially how it works. And with regards to the API, I wasn't particularly involved with that, but I know that I would definitely be able to put you to the individuals that were, and also Maris as well, where they host us, so they would also be able to help with that.
Okay.
To get it right. But it was mostly things like, it was only outputting 50 records, you know, when we wanted to be outputting like 100 per list. Do you know when you have those options like 30, 50, 100, all of them? You know, little things like that. The defaults just weren't exactly the most intuitive. That was my understanding from the feedback that I received at the time from my colleagues. But yeah, definitely glad to help out and share knowledge on that one.
Thank
100%.
you.
Thank you so much again, Colin.
Thank you very much.
And by that, we go to the next speaker, which is Sebastian Miro, and he wants to introduce the topic of his talk himself.
Okay. So, where is it? Sorry? Ah, it's here.
Da, genau. Jetzt musst du da.
Here?
Und dann Full Screen.
Full screen. Okay, great. So, yeah, great. I would like to talk about WebODV, which is the online version of the Ocean Data View software. One moment. Oh, no, sorry. I want to talk about quality control. Okay, good. Sorry, that was a joke. So I want to present a new online app for ocean temperature quality control. And this is an AI approach. And this is a teamwork together with my colleague Mohamed, who's over there. And we worked on this topic now for a couple of years. And but I would say it's still a bit preliminary. We are still in an exploration phase. So let's see. But it has the potential for sure. So the goal of this project was to set up a web application where oceanographers can do quality control on ocean temperature data. And this is the app. And it's online, it's operational, it's running under the URL mvre.autoqc.cloud.rv.de. It's a bit long, but this was in the frame of this MVRE project. And we have a couple of documentation there and some slides, so you can read about how to use it. It's about quality control of ocean data, which means we want to find anomalies in data, detect errors, and actually it's a very simple app. So it's just a 3-step procedure. So you just upload your data, then it's processed in the background, and then as soon as it's finished, you can download the data quality controlled. But I have to say it's still, let's say, in beta mode. So please, use it, test it, and report back to us, and don't use it blindly, okay? Okay, so the input data. We started really simple. So it's a CSV file, and we have it's a column-oriented file, and it's mostly about CTD data, also maybe bottle data, but ocean profile data. And we have here a couple of columns which are needed, like a profile number, longitude, latitude, the depth, and the temperature. Other columns are optional. So this is how it looks like. So you can upload the data in this way. Yeah, and what do we want to detect? We want to detect anomalies. I don't know, sometimes we can call it errors, sometimes only maybe suspicious data. And we call it spike and suspect gradient. These are the two kind of features we are interested in. So after uploading and processing the data, we get the data back from the app. And what we did is we include 2 extra columns. We call these columns TRADQF and MLQF. And you see these extra columns here on the right. And TRADQF means traditional quality control or classical quality control. And here we apply some classical checks, which are, for example, very simple range checks to detect anomalies. And then we also apply the machine learning to even improve the results from the classical checks. So what is the AI actually doing? What you see here highlighted is where the classical check detects a spike and it gives it a flag, a 4. A 4 is a spike. And the machine learning checks it again and gives it a 0 and says it's good, actually. So the machine learning checks again the results from the classical procedures and decides again, okay, do I accept that, what the classical algorithm says, or do I change it? But how can the machine learning know about that and correcting it somehow? And the answer is, we trained it with human expertise. And therefore, we have to look at the classical approach. And the classical approach, we also heard it, for example, yesterday from Marina and others, is, a profile is coming into the system, then traditional quality control checks are applied, like range checks. And if this profile is considered as fully good, it goes into the archive. If we detect at least one suspicious sample, it goes into the visual quality control. And a human expert looks on this profile and looks on the suspicious samples. And then the human expert decides, okay, do I accept that? Or do I maybe change it back to good? And this was an approach that was done at RV. And we trained a neural network with exactly that, what a human is doing, checking again the classical flags and then decide, okay, is it really bad or maybe I change it back to good? So we trained a neural network to really imitate the human. And we put it into this pipeline to support the human. And the idea is, of course, a workload reduction for the human, but still the human is needed for, let's say, final checks or corrections, however they want. So yeah, maybe I don't go into the details here about the evaluation and the skill of the model, but the crucial point, so here you can see the confusion matrices on the left from the classical checks, on the right from the classical checks, plus the AI checks. And the crucial point are the false negatives, which means this is where the classical check says, oh, it's bad, but actually it's good. And on the left, you see for the false negatives, the classic check found 2,400 roughly. And then we applied the AI on it, and the AI turned roughly 2,000 back to good and put it into the TP, the true positive, into the good. So it's exactly doing that what also a human would do, because this is what it has learned. And this is a real workload reduction, but still, please, it's a bit preliminary, so we are still testing and doing some more checks to make it really more mature and reliable. Okay, so how we did all that. So we started with a large Arctic database we have at RV. It's called the IMDIS. It contains more than 280,000 temperature and salinity profiles from different sources. It's an Arctic data set, so this works only for Arctic data at the moment. This has been quality controlled by our ocean experts, and so that means we had a large labeled data set to train the algorithm. Also, we implemented all the classical quality control checks in Python, Jupyter notebooks. We set up the neural network, which is in this case a MLP model. And then we did all the typical AI procedures, training, validation, evaluation, and we created the app and implemented everything in the web. Okay, so yeah, for the future, this is all really new and fresh, but we really think it has potential. But of course we have to finalize everything, make it more mature, reliable, do more tests, and so we want to also put everything on GitHub. Also the code for training, for evaluation, everything. So not only the app, which is very easy to use, but also the code. We want to apply it on salinity. So there's a colleague at AVI, who I'm working now together, and we are looking now on salinity, of course, improving algorithms, and somehow, of course, the end goal is to implement that into the community, CDataNet, EMODNet, iQuad, and there are other errors, like statistical screening errors, how they are called. It's like comparing data with climatologies, and so could also be used to develop more AI algorithms and use other data sets, other QC operators. So yeah, there's a long way to go probably to make it really skillful and useful, but I think it's possible, so thank you.
Thank you very much, Sebastian. Finally, we're talking about AI. I'm so happy. Questions?
Yeah, actually, I had two questions, but you already answered one about comparing to climatologists, which is obvious like step. And second question, you considered the stabilization of the profile and density inversion could generate some errors from the AI point of view.
Sorry, can you please repeat? I didn't get it.
Are you considered to check for stabilization?
Stabilization. Yeah. You are talking about something like density inversion.
Correct.
Things like that. Yeah. So this is included in this traditional quality check pipeline. There are checks for density inversion. But as far as we know, it includes no visual control. It's purely algorithm, and it was accepted from this classical algorithm. If there is a density inversion, accepted. Okay. So, which means if there's no human influence, the AI has nothing to learn. So then we can use the classical check.
Yeah, I'm asking because when we were preparing the latest World Ocean Atlas, we saw some effects from automatic stabilizations which needed further intervention.
Yeah, I mean, if we have that in a data set labeled, fine, we can use
Good.
it.
Thank you very much.
Hello. I saw a rock curve, a bit square. Is it risky in terms of overfitting or no?
So the rock curve?
Yes, it's a bit squared. Isn't too overfitting?
I mean, good question. I mean, we of course, we considered overfitting. So we did a validation with a loss curve. So, I mean, the model was learning, and at a certain point, the loss was increasing again. So we found the optimum. And so I would say, I don't know, I cannot rule out. But normally, according to all these steps, there should be no overfitting. But do you think, or I'm not aware of it. Is it a sign of overfitting if it's this shape? Yeah, but it's also a sign of being very skillful. If you have this. Yeah, sure.
I've got a mic over here. Have you been able to pull out any insights from the change in false negatives of what it is that the classical checks were missing and what's being picked up now?
Unfortunately not. And because this UDASH data set has been created a couple of years ago at AVI, so the problem was we just took it as it is, as a kind of truth. But I mean, of course, we looked into profiles, and for a certain number of profiles, we were really wondering what's wrong here, and this is something, yeah, I mean, we also need the experts to work on that. And especially if we think about things like that, it would be ideal to go into a loop, like the so-called adaptive learning, which means we have an expert which checks the results are checked, they go again into the training, the model improves, and so on, to make it final. And
Okay, thank you, Sebastian. We have to move on to the next presentation. Sorry. So Dick, you are the next one. About Imagine and the AI-supported imaging data and services for ocean and marine science.
10 minutes? Okay. You have to first find it. But this is the last time you see me on this platform today, okay? But how do I close this one? There's no cross in the corner. Yeah. Oh, really? It works like that? Yeah, this is PDF. Can you see mine, by the way?
This?
Yeah, imagine. You're right. Okay. Imagine there are... Come on. Also again, so slow. This is,
but this didn't work. Try again.
oh, okay.
There you go.
Yeah, okay. And now we go full screen.
Yes.
Yep. Yeah, you can see. Okay. Okay, this presentation about the project called IMagine, and it's about artificial intelligence, especially for imaging, and then from macro to micro. So we look at, say, satellite images up to microscopic images, and everything in between could be a topic which can lead to a use case. Now, first of all, let's say there's a little bit of a relation here with, of course, with all the data that we are collecting. And we say, well, there are a lot of infrastructure already, let's say, for the normal data, we call it, but there's hardly anything for image data. And that's why in this project, we are developing more capabilities in analytics for imaging, but also we look a little bit at how to store that data and make it available for others to use. Strange this. Sorry, but it's all micro here, what I have to make it a little bit bigger. Because okay, yes, okay. Let's say what we did in this project, let's say we, first of all, there is already quite some work done by our colleagues from Spanish and also German institutes, and they developed a lot of, let's say, a workbench to develop, to test, and to deploy analytical services, AI services for images. And we make use of this workbench, and we, let's say, we make it fit for use cases, especially in the aquatic community. And therefore, we also develop what we call a portfolio of use cases, and we also have open calls to extend that portfolio. And in there, we set up prototype use cases, but also we go from some prototypes to mature use cases. So we look at so-called technical readiness levels that we want to make them higher. And also from this, we want to derive best practices, or better practices, or let's say less mature practices. But anyway, we want to derive, let's say, a learning curve, which we then can also, let's say, populate in the systems that we heard about today. And this way, bring over this experience also to others who want to adopt the same principles. And finally, we have this workbench. The workbench is being supported by resources from EGI, which is the European Grid Association. And they are also, we have a certain amount, let's say a certain number of resources in GPUs, in CPUs, in storage. And that can be used also for others who want to work with this. And that's for now, of course, during the length of the project. But at the same time, we're looking how we can connect this workbench as part of, for instance, the Blue Cloud, so that we can continue and have, let's say, a longer perspective for this platform. Now we have 4 national computing centers. That's for EGI. Let's say they support us in the back end, the infrastructure. Then we have a number of institutes which are really in the AI and machine learning developments. And then we have several research institutes which are involved in the use cases. And a lot of them, they make data, use, let's say, data or are related to certain research infrastructures. So that's a little bit the landscape. And my role in this case, let's say I'm not a technical coordinator, which I normally am, but this is not the field where I am an expert. But I'm in this case more a scientific coordinator, just to try to get the portfolio together of all the use cases and make the connections with our community. So we have one for aquatic litter drones, and that's, let's say we have drones at the German Institute. They collect by drone images on the beach, and then you can use those images, of course, to identify and classify, because that's all the time what we do. We have an image, and you do identify, classify, try to separate objects, and then try to classify those objects following certain, let's say, standards. Another one is SUSCAN Ecutaxa. That's for the Sorbonne University. And that's what they say microscopic. And they do taxonomic identification. Then we have the marine ecosystem monitoring. And that there are 3 EMSO sites which we are in the project. And you have seen already a presentation earlier on EMSO Ops with the fish detection, our colleagues from Spain. And that's also one of the examples that we use a lot, because it's very easy, let's say, to understand what in fact is happening, and very illustrative of the work in the project. They have another one is with CMCC, and that's for oil spill detection, so using satellite information. And there's another one which is called FlowCam phytoplankton, which is a little bit comparable to the SUSCAN Ecutaxa pipeline, but they do something different, but it's quite comparable in the same line. And then we have a couple of what we call prototypes, because all these 5 that you saw, they were already quite mature, but in the project they are going to a higher level to be more, in fact, to become operational. And that's the challenge in the project. But we also have some really prototypes that we don't expect them to become mature, but it's try out with groups and bring them further. One is for underwater noise, which is also a very important indicator. So if you look a little bit at the portfolio so far, is quite following the MSFD, let's say the indicators. We try to get different examples. Then we have the beach monitoring, and another one. And that's done with beach cameras, and also looking at, let's say, the Posidonia, the detection. And then we have freshwater diatoms identification, which with microscopes again. And recently we had some open calls, and from this we have one group that wants to study the satellite-derived bathymetry. And using, again, let's say, the images, let's say, from satellites. Another one, improving knowledge about cold water coral reef. And finally, we have now one which is looking at fish otoliths. And there are little bones, let's say, in a fish, and from this you can derive the age of the fish. And it's all quite interesting, because a lot of these things are being done already for a long time, but by manual intervention. And there was a little bit what Sebastian was explaining. We try to use the AI to speed up the process, make it more efficient, and also maybe more consistent, because humans can also have a bad day and a good day. We know that. And machines have that less, I think. Okay, so we go from data to knowledge, and that's of course the whole principle of why we collect data. And we have this Imagine AI platform, which is then available supported by the cloud, and we have these use cases, deployment. And then there is already a marketplace, and the marketplace is open for the Imagine. And you can find, on this marketplace, you can find the methods and the principles, but you also find the use cases and also documentation, let's say best practice documentation about the use cases. And this is an ongoing work. It's also connected to the AI for EOSC, which is, let's say, a larger initiative by the Commission, and it's the same technology is behind. And also, in fact, the same research group who developed the workbench is also behind AI for EOSC. In this sense, there are now 2 or 3 projects working in parallel on the same platform, more or less. But we are especially going for the marine application. Let's go a little bit further. Another thing that we want to do, because we are looking for best practice, is also we want so-called synergy between the different use cases, and therefore we have a competence center approach. That means, in practice it's work package 3, but we call it competence center. That means there are every month meetings where all the use cases explain their progress, and then in fact they learn from each other. And we also have, I would say, a little bit a teacher, like Valentin, because it's a little bit acting as a teacher, because he is very experienced in this domain, and he helps the use cases in a technical sense, and also in just to bring it further. And also, of course, to help them to get more acquainted with the platform and the principles of the platform. And at the same time, the use cases, they report back the progress, and that of course gives insights and also requirements for improvement. And in that sense, it's a very nice synergy, and you get from these best practices during the project. Now we have done key exploitable results, because nowadays, of course, in all the European projects, we talk about curves. You have to make something which is worthwhile to continue and to exploit. One is, of course, the framework itself and the computing platform. Secondly, we have these 5 operational cases and the 3 prototypes, and they are now expanded with some new prototypes from the calls. And finally, we have these best practices, which will open it up for a wider audience, let's say, to adapt and adopt. We have some preliminary results, and that's the use case. Our friends over there, they're smiling, because this is, we use it everywhere, but you have already heard their presentation, so I will not go deeper. But we have some lessons learned, is that, of course, the labeling is very important, the data preparation, because without a training database, let's say, it's, you can't get good results, and that's very laborsome to do that, effort intensive. We need more metadata, because we want to, some provenance, let's say, we keep good metadata and also of the labels, label data sets. We need high quality open source AI models, they exist, so there are several, like YOLO V8 or YOLO V9 nowadays. Let's say there are several of these models already on the market. They're open source and you can use them. And some of them are very good results. And then you have regular knowledge exchange is important. That means that we work together with this competence center, as already said. And finally, we also are looking at, say, how we can bring 2 things, in fact. Let's say one is that we have these resources, but it's more the computing, let's say the GPUs. Because in the beginning we made a mistake. We had the GPU we had a certain resource, but then there was not, let's say, an obvious button to switch off the GPU when you were not using it. And then in the first months of the project, the GPU time simply went on without use, in fact, but it was, the resource was gone because it was not, and therefore, luckily the provider said, I do it like this over my heart and I give you another volume, because otherwise the project was already, let's say, almost everything was gone. Finally, let's say, what's also important is then, let's say, the fact that we have this best practice coming out, which we can share with the community. There is an open call. It's again open, because it's in fact a continuous open. So if you're interested, you have a subject, you say, I need some computing, I want to try it out, then you can make an application. Application is very simple. We have a steering board every month, and then if there's an application, we check it, and we do a small review, and if we like it, we say we do an interview with the people that proposed. If that clicks, and then we continue. Important is, when you make a call, that you really have the time yourself, let's say, then to work on it, because it's not that you can give us something and we do it for you. It's really, there is a workbench. You will then be part of the competence center, so people help you to set up your case. But you have to do all the groundwork yourself, and also it helps, of course, if you already have the data for your training database. Let's say you can still do labeling, but you must have already a very good database to start with. And that has, from the experience, let's say, it must be quite a large database, because then you get much better results, and you can also do calibration afterwards. So okay, thank you for listening to me.
A very nice presentation. Again,
you're welcome.
I hope there are some questions. I'm looking for a specific person to ask a question. Otherwise, I would ask that question.
If they're too technical, I look at my colleagues from Spain. Okay.
There you go.
Yeah, hi.
For you first? No.
Yeah, I was wondering, so the output of these AI models for fishes, I'm supposing like at some point all these detections will go into like some tabular format. Are you planning to put it in Darwin Core, submit to IMDIS Biology? Is there future plans for that?
Now there are two, let's say, if we look at data, let's say this, first of all, we have the training data sets, and those are being published right now in Zenodo. Because we have also an IMDIS community on Zenodo where all the deliverables of the project are available. And also then, let's say, the training data sets, the labeled data sets. Secondly, we have asked all the use cases, the mature ones, to make a sort of business plan, how they see going to production. And that includes also the, let's say, the input and the output data that they're going to generate by using the algorithms. And that's, it's a little bit, let's say, we are now just finalizing the deliverable, that where everybody tells how they want to manage more the results, if they want them also publish them as a Zenodo, or that you say it's just, let's say, a repository, and every user has his own part of that repository. But that's the use data, let's say. But the training data sets, they are really documented, and they are on Zenodo. And we are also working now with Zenodo on, because Zenodo itself is a little bit, let's say, oriented towards paper publications. Let's call it like this, the format. And we are now working together with Zenodo on a Zen project to make a more dedicated data collection format, which will be a DCAT format. And that's very interesting because the Zenodo group says we really want to, I say, help you. And for them, they see it as an enrichment of the Zenodo capabilities. And they have also a project, in fact, Zen. And I like Zen. I want to be feel Zen, okay?
Yeah, thank you.
Yeah, sorry, I'm a little bit joking, but you know what I mean. End of the day. Good? Anybody else? Yeah? Mark, go ahead.
Especially in the last thing you were saying, that there's again a bridge to make to linked open data and RDF.
Yeah.
And basically in the application of the technique called fair signposting, because you're dealing with images, and when you have the link directly to the image, fair signposting will allow you to link to the metadata. And that's really something I would, recommend looking
in this
into.
case, let's say, in this case, we are not going to the one-to-one, let's say, the metadata, but we talk about the collection as a whole. So it's, let's say, it's a package, and the package is being documented in the format that we are right now developing together with Zenodo. It's not yet the one-to-one metadata of each individual image, let's say. That's not what we are, you understand?
Yeah, maybe we have to take it offline, but...
Offline, okay, we do it offline. Good. Okay.
But you have a very valid point here. How do you connect the classification to the original images? So let's take that offline.
Yeah, okay, good. Okay, then.
Thanks again, Dick.
And thank you for listening the whole day to me, okay?
It is now time for a coffee break, and I'm not sure, maybe you want to say that, but you only use one word. So you can say coffee, and I can say you have to be back at 4 o'clock because we have wonderful posters here. I promised you 36. There are only 31 because I had the wrong version of the program, but still 31 posters to look at. Please be back at 4 o'clock. Perfect. Good. Thank you. That was another word. Great.
Hello, everybody. I like to gather everybody in front of the stage. There will be a photo. So line up here. Put the smile on. Now, gruppebilde. You will be lying in front. Everywhere. You can be in the middle here. Facing that way. Charles will take the picture. And the next message is to sit down, please. Be ready. It's 5 minutes, but well, we are getting very fast now. Yeah. Somebody can tell a joke or something.
Nobody thought that you would ever behave so nicely. Now we're ahead of time. That's not possible. Okay, up there? Cool. I believe we are hearing about this now. Is that right?
Yes.
By Luca. Luca, stage is yours, please.
Thank you very much. Let's see. Yes, thank you. Thank you for the introduction. My name is Luca Lamoni. I work as a data analyst at ISIS. Today I want to talk to you about Advice Explorer, which is an app that we recently developed at ISIS. I want to note that my colleague Sarah Miller is also here, so if later you have any question about the advice process, she's the right person to ask, not me. So just a few key points about ISIS as an organization. ISIS provides scientific advice for a variety of topics. It provides data and scientific products, as you probably may well know, and also scientific cooperation. Today we will focus on a specific type of scientific advice, which is the advice on fishery opportunities, also also known as single stock advice. So how the ISIS advice process works. Usually we get an advice request from one of our clients. We gather the people, the experts that are best suited to address this advice request. Their work is then peer-reviewed, and ISIS then finally release the advice. How do we release the advice? Using PDF documents. Now, I know we all love PDFs, but in some cases they are a bit limited. And so a few years ago, we decided, what about trying an interactive approach in displaying this type of advice? So probably here I'm preaching to the choir, but there are several good reasons to move from a static PDF to a more web-based interactive product. I will just mention three. First, we can provide the user with interactive data visualizations. And in some cases, for certain type of plots, this enhance the user experience. We can provide direct access to the data that is used to build these figures. And finally, easier integration and connection to multiple ISIS products. So then the question is, what is Advice Explorer? Advice Explorer is a shiny app that was developed between 2021 and 2023. It was released in June last year, so almost a year ago. It has two main goals. The first is to facilitate the visualization of the advice on fishing opportunity. The second is to make it easier for the user to access directly the data that is used for this advice. It is fully integrated with ISIS databases and services and processes. And what I mean by this, so Advice Explorer is very visible, is online, is working, but there are many processes under the surface that are key, are fundamental for this app to work. These processes include people. So, for example, on the left-hand side, you see the advice process, the expert groups, the ISIS Secretariat staff. On the right-hand side, you see the more data infrastructure aspect, the Transparent Assessment Framework, TAF, the ISIS databases, and web services. I will now focus on the ISIS databases, which really form the foundation of how this app works. We have three main databases: the Stock Information Database, SID, which contain the general information about the stock; the Stock Assessment Graph, SAG, which include the main data of the assessment; and finally, the Advice and Scenario Database, ASD, which was developed together with the Advice Explorer, which contains the headline of the advice, so the official advice that ISIS provides, and the catch scenario tables. The Advice Explorer pulls all this data from these three databases and harmonize it for the user. So what can we find on Advice Explorer? Here on the table, you can see the years of stock assessments we have at the moment. ISIS in general publishes around 180 stocks advice every year. So we are in line with what has been published so far. For each stock assessment, the user can download trends over time, which include landings, recruitment, fishing pressure, spawning stock biomass. It can visualize the catch scenarios, as well as access links to ISIS resources. So now, let's try to see if this works. Okay, click to connect. Enjoy your stay. I'm enjoying it. Okay, so this is the landing page on the ICES website for the Advice Explorer. You are seeing it? Yes. So this is how the app looks. The different tabs on top reflect the different sections that we have in the Advice data sheets, the PDF format. On the left, here we have a filtering panel, which is made of an interactive map that can be clicked, so you can select one or more ecoregions at the same time. If the user wants to do a more in-depth filtering, it can select the assessment year, the stock code. If for example, a stock assessor knows already the stock code they are working with, they can select it from this drop-down menu. Or let's say we are interested in haddock. Oops. Then we click, and the list on the right, the list of stocks, is updated. So once we find the stock assessment we are interested in, we click this button. This puts us on development over time. So here we have two top panels. The one on the left sums up what we have selected, the stock we have selected, and the year. The one on the right contains the headline advice, so the official message that ICES publishes. If we click on the title, we are directed to the ICES library, and there we can access straight away the PDF of this advice. We can download the data using this button here, so the data that was used to build these 4 plots. Here, for example, depending on the stocks, we have different variables that are shown, but for example, here we have catches, recruitment, fishing pressure, and spawning stock biomass. All the plots are interactive, so we can go on top of it, check the values, zoom in and zoom out, save it as a PNG or as an image for a presentation. And then I would just move quickly to the catch scenarios and skip the quality of assessment. Here, the two top panels are the same. Here we have a direct link to the ASD database, so we can check the full entry and the metadata. And then here we have the button to download the catch scenario table. On the right, this time, the right of the screen, you can see the catch scenario table. The top row, the one in bold, is the scenario that has been chosen by the expert for this specific stock as the basis of the advice. On the left, we have this plot that is just a representation of this table, the values on this table. So we have fishing pressure, catches, and spawning stock biomass, and the effect that the different scenarios, which are represented by the dots, have on these 3 variables. Down here, we have 3 additional plots. I won't go too much into detail, but these are alternative ways to look at the catch scenario. So here, for example, we have a catch time series. We can add different scenarios and see what is the effect of this scenario have on next year catches. And finally, we have some resources. So we have, for example, a feedback form that you can fill up with general ideas or things that you see that don't work. So we receive this feedback, and we usually act on it pretty quickly. You can also email us or visit our GitHub repository. All the code is stored there and is free to use. We also have some list of data sources, data disclaimer, and a citation. So do I still have a minute? 1 minute, perfect. This was my plan B. So ICE's vision for the future is to develop a suite of web-based interconnected applications. So the general idea would be to allow the user to move between different regional level, to move between different scales. So for example, we are working on the Fishery Explorer, which is based on the fishery overviews, which is ecoregion specific. And then we hope that, for example, if a user is interested in a specific stock, from the fishery overviews, we'll go to the Advice Explorer. If the user wants to dig even deeper, we are working on an app called TAF Explorer, and this will show the code that was used for the assessment, the results, all the figures that don't end up in the advice sheet, and it's based on the TAF approach. So I think I'm done. As you can see, many people contributed to this project. So I would like to thank them here and thank you for sticking around. Thank you.
Thank you, Luca.
Thank you.
Do I see hands? Come on, come on. There you go.
Yes. Okay. No, sorry. Yeah, it's not a technical question, but a content question. Because we saw the haddock, and you saw that the volume went down enormously. But is that because the consumer don't want it anymore, or because the quota, the fish?
That's. I think it's a question for Sarah, if she wants to answer.
Sorry, I don't know what haddock was. It's quite specific haddock question.
Let's see.
Now, because I know in Dutch, let's say schelfish used to be the most cheap fish that was around, and it was eaten. Let's say the last years, you won't find it in any shop, I think. But is that because it completely went down in population, or because people don't want it anymore?
No. It depends what ecoregion you're thinking about, but for instance, if we look at the North Sea, it's because we fish haddock in a mixed fishery, and we have a very small cod stock these days, so that's limiting how much haddock, which is actually a very big stock right now. So there's a few different issues, but it's not, I wouldn't say it's because people don't want it, no. It's a bit different in the Arctic, if that was the one that if you were showing. I think it's still pretty healthy.
Thank you.
Hi, thank you. Beautiful presentation. I was wondering, maybe you said it, apologies if you did, but who, the users of these reports, who are they, and did you include them in developing the tool?
Yes, that's a very good question. And it was on a slide that I didn't include for time reasons. So during the development of the app, we created a user story group, which included a representative sample of the potential users, which obviously the app is mainly focused for people inside the ICES network, so scientists, stock assessors, policymakers, and I think managers in general. So we did include them, and I have to say it was very beneficial. They gave us really good insights, and they helped tremendously the development of the app. We still, from time to time, receive very good feedback, which help us kind of direct further the development. Thank you.
So I think we are going to the last presentation from Sigmund Klückner about assessment of online translation tools for indigenous language in the ocean domain in the Arctic.
I swear this is the longest sentence in the whole presentation. I'll try. Do I find my name? That's the bigger question. Oh, here I am. All right. Good. Welcome to the last presentation on the last session on the last day. Almost got it. How is the energy? Yeah? Okay. Because I want to know something from you. Show me. Whose mother tongue is not English in here? All right. Except for English, obviously you understand, and your mother tongue. Who speaks a third or a fourth language? All right. Who thinks they can explain climate change in that language or any other third, fourth, the least one that you speak enough? Well, yeah, the one you think you're the least fluent. Right? That's already pretty hard. Who speaks any languages of the Arctic, including Kalaallisut, Inuktitut, Inupiaq? Anybody? No. Okay. Me neither. This was a fun project for that reason. But now exactly that is happening a lot, that we have those third languages spoken only by a few thousand people. So what do you think the odds are that you can correctly communicate scientific or topical knowledge? And this is what this project was about. It's more about almost scientific communication, more so than anything to do with ocean data or information. But we try to look at this from an ocean perspective, from the ocean domain in the Arctic as part of the Capardos project, which I mentioned before. So the question was, why are we doing this, right? So there is a lot of knowledge and information is published on the Arctic and on ocean topics. The information could be very useful for local indigenous communities. However, a lot of it is published in English or other major world languages, think French or Spanish, which can add an access barrier to that information. So our question was, can automated machine translation even help? Automated in the sense of, can a computer translate this very well or well enough so that others can understand it, that whose mother tongue is not English or where exposure to English is little. So Ute, I saw your question. This is exactly why we started. It's like, can it even happen? And yeah, the results will come in a minute. The background, again, also was the languages in the Arctic are spread. They partly share the same roots. Here you can see the map of dialects, of the biggest dialects in the Arctic, everywhere from Greenland to Alaska. Some of them share same roots, but they are not mutually intelligible, or not all of them. And they are considered what is called a low resource language. So there are a few thousand speakers, there are a few written artifacts, and there are a few documents that have direct translation to another major language. And in comparison to a major language like Spanish, English, you have billions of people that speak it probably. Those a few thousand, there is not enough for machines to actually train models onto that language. And for that, also the ocean information might not reach these remote communities, and remote not necessarily geographically, but also language, on a language perspective. So what we did, because this was out of sheer curiosity really, it was a very short project, we tried to do 3 things. We did desk research on existing tools, so what's even out there. We focused on neural machine translation tools. We looked at the support for a sample of 15 relevant languages just to see the breadth of what different tools can do. And we compared a few of those features because, as you might know, and it'll show up later, Google Translate, for example, can do images and documents, and then some can do web pages. And so we tried to understand what is even possible within those online translation tools. We did a general quality assessment of 6 tools, meaning that we used the same test document that you can see there on the screen, and sent it through those 6 tools. We took the target languages of German, Dutch, French, and Danish. This is based on the limitation of the team members or associates who can then actually quality assess that. You know, it doesn't help if I translate it into Spanish and then I can't read it. And then lastly, we also try to understand the translation capacity of systems into Arctic languages. So which tools are even available and what's the quality of that. And we based that on a few documents that were actually written in an Arctic language and were translated into English as well. So we could compare the outputs of computer versus human translation. Quickly, what we found, 43 tools were cataloged. Before that, I thought that Google Translate and DeepL were the only ones out there. So that was very interesting. A few of them claimed to support Kalaallisut and Inuktitut. Kalaallisut Greenlandic, Inuktitut is Arctic Canadian, I want to say. And there is, for example, no support for Inupiaq or Sami. So Sami, northern Finland and Sweden. The quality assessment, Norway also. There you go. I'm just testing if you're listening. Hey, this is the last session. Huh? All right. So from the quality assessment, from those 6 that we tested, overall DeepL and Google Translate scored highest. They had the best quality in terms of consistency. They had the symbols that we had in there that we tried to trick the systems, you know, with chemical symbols and names that they might not have normally understood. But from all of the 6 tools, Google Translate and DeepL came out best. We also tried a diagram. This was the challenge that there was, with little context, the translations are obviously worse, just because that's how the NMT, the neural machine translations work, and the models. If you're curious, all translated documents you can find in that link. So if anybody speaks any of those languages, feel free and let us know what you think. Obviously, the assessment that we did was a very subjective one. On that last point that I mentioned before, translations from Arctic languages, in the end, there were only 2 systems. One that said Inuktitut, yes, we can do. That was Microsoft, and then Alibaba said that they can do Greenlandic. Here I have an excerpt from the report People of the Ice Bridge. The Inuktitut, kind of hard to read for most of us. But I highlighted one of the challenges that I found here is that the classic one, that weather and climate change and weather change are sometimes confused, and so did the system, right? The human said, but today there is climate change, trying to give that argument, while the translation said the weather is changing, which technically, if you interpret it, yes, you can, but given it like that, there's a good chance that this might not work as a translation for a scientific output, since you want to be exact. One other thing, Christian mentioned OBPS today already, so don't have to mention what it is. Y'all know that anyway. We also did a translation during that project where we did the Goose and Dorsch practices that are in OBPS, and we translated them and we sent them through Google Translate. And what is interesting for us is that the uptake is actually fairly high. From those few, that the translations are actually also interesting and also have been downloaded quite a bit. So you can see here 2 examples. The first one was even deposited in English, uploaded in English in May of 23. And the translations were actually also, if you sum them up, pretty well downloaded as such. So we take from that there is interest. Now, how good those translations are is another question. That's the jury is still out on that, so we're still waiting for feedback. But overall, I think it can be a helpful tool for for getting your information and knowledge further out. That's pretty much it. Overall, machine translation can be a useful tool, but mostly for major languages. So Ute, your face was right. There is not enough support yet. It can convey, they can convey the gist of the message, but it's still tricky to convey details, especially when you're trying to convert or to convey scientific messaging. And definitely don't skip the human quality check if you're using these systems. So I mentioned there are no high quality models yet for low resource languages, which, for example, the indigenous languages are. There are some organizations working on it. For example, Meta is developing the No Language Left Behind models. They are currently supporting 200 languages or so, and they're growing and growing. Then this project has been done a year ago, and generative AI models are getting much better at translating. There was a recent demo of ChatGPT 4.0, where they were really conversing in another language. Or you might have seen those funny lip sync videos where somebody speaks in one language and then the system translates it and also adjusts the video accordingly. And yeah, so automatic translations, to sum it up, can help reach underserved populations, but you need to be very careful. And with that, I'll leave you with the Babelfish, which some of you might know from Douglas Adams, the little fish that translates every single language into everything else. Until we have that, I think we'll just have to keep making sure that our messages are in and very, very concise in all the languages. Thank you.
Thank you so much, Sigi. That was a great showdown.
Thank you.
Questions? Comments? My comment is that Sami would probably work with Norwegian, but you didn't have any Norwegian in your project.
Correct.
So, yeah.
Well,
Next time.
and we didn't have any systems who would actually translate into Sami.
Ah, right, yes, as well.
That's
But
the other-
because Sami is so, it's everywhere in Norway, isn't it? So that should work.
Yeah, and I mean, we did look at Danish, Greenlandic to Danish. There is a
right.
system online.
Yeah.
But then again, if you have an English document and you want to translate it into Greenlandic and you have to go through Danish, there's obviously then the three-hop problem that you're playing telephone in the end, right? It's like.
And what goes often wrong is if it's a positive sentence and then suddenly it's a negative or vice versa.
We actually also saw that in the.
Yeah. Hi, Sigi. You know, when it comes to data management and data management principles, we have the CARE principles that is developed by the indigenous people. And since we are talking about, you know, semantics and interoperability on the data level, there are certain issues related also to, you know, the language. How do you integrate those CARE principles when we are discussing this language here? I mean, did that come up in your discussion at all?
It did not. I have to say we did this project in about 2 months, so it was a quick turnaround. But I agree, and also there is a good question about semantics and how you translate different words, because you also have in different languages one word means this and the other, and you can translate it into 2 different words depending on the context. But then on the way back, you'll do this. We actually tried this out too, that we wrote something in English, translated it into Dutch, and then translated it back into English. And it was funny to read, let's put it that way. But some of it also, the writing is actually then at some point is better because the systems are trained much better on the data, so they actually use potentially better syntaxes than native speakers would.
Just a comment on that. So CIs, for instance, that's an observation that is interesting, and where you can have potentially a richness from these indigenous groups that we are lacking from observations.
Yeah.
But then you are entering into this CARE principles where ethics and ownerships and you know, understanding of who is giving the data, so data providers in this
Correct.
case.
Yeah.
So that would, I think that would be interesting. There's a lot of value to be captured from that.
Thank you.
So it's really cool work. When I was in China last year, one of the revelations to me was I can talk at my phone in English and it can talk back at people in Chinese. And they can talk at their phone in Chinese and it can talk back at me in English. So the real-time translation services for some of the Far East countries have now got to the point where they're actually pretty advanced and very reliable. Have you tried this type of work with those languages where those mechanisms are actually now much more mature?
In that project, we did not. No. We focused on the low resource languages. I have to say we did try at that point with ChatGPT and others, but at that point they weren't even as good. And it wasn't a translation; it was more an interpretation. So you can't also not know if it's actually what you've said, if that's conveyed correctly. But it's definitely gotten better. And I agree, those things are really cool.
Okay, everyone, what a great day, wasn't it? Thanks, Iggy, again. Applause. And please an applause to all the speakers today. It's locked again. So I wanted to try to give you a very, very short summary of the day, of this great day. We started, I like this circles always start with why, and I think we had a very, very great why with the first keynote on the digital ocean in Ireland showing us why we are doing what we're doing. And then we had a lot of talks about the good platforms, the good systems that we have in place, and how important it is to have this high quality data that we put into the systems. And then we've moved on, and then we had all these platforms and the virtual labs who showed us what we can do with this data once it's there and it's quality control. This was really great and very informative. We had fabulous posters. I'm not sure if everybody has seen all of them, but they were really, really great, I thought. And then in the afternoon, after the poster session, we had now these two examples really for policy making. And then Sigi reminded us that we really leave no one behind. And that is also one of the things that we say in the Ocean Decade. And it's really important. You reminded us of the CARE principles. So we are very rich here in Norway and in Northern Europe and in the Western world where we live. We have good internet, we have lots of data, we can work together in these great projects, but there are other areas in the world where that is not the case, and we cannot forget that we are also making these solutions for these people, so leave no one behind. And I think that was the summary that I had. I would like to thank you, Christine. Merci beaucoup.
Thank you too.
And yes, thanks for a great day, all of you.
Yes, thanks to all the presenters who have made this conference very successful. Thank you to all.
And of course, the greatest thank you to Helge, who is the brain and organizer behind all this, for the good food and hospitality. Thank you.
Thank you. Just have a few remarks. Maureen, something about files and videos, and Serge first. Some closing remarks.
So yes, unexpectedly I've been asked to make the closing remarks for this very successful conference. So first, I missed something, that I attended several conferences with many of you, and once in a while Charles takes the floor and imposes us some stretching exercise. So it didn't happen so far, but I would like you to thank there are still 9 persons remotely attending. So if you could wave your hand and say hello to these 9 colleagues. So this is a stretching exercise. We are getting old, not too much. it has been up to 15, you said, people attending remotely. So this make, we are no more in the period of COVID, so that, of course, is a very decent number. This AIDS conference, IMDIS conference, was very successful. I think that the quality of all the talks are remarkable. Well, we started to thank people, but we have a lot of people to thank you, because this is a vivid conference. We have exchanges inside the room, but also outside in the lobby. I want to thank the local host, the organizing committee, all the old friends that were also present in the room. Also, they are not involved professionally anymore in this activity. Michelle, Leslie, I shouldn't name people because I will forget some, but give an applause to this team that launched this series of conferences 17 years ago. The moderators, the speakers, everyone, the technical team, thank you. The welcome team, everyone. The last point I would like to mention today is, if you like IMDIS, please support IMDIS. And how can you support IMDIS? By welcoming the next edition. Think about it. In 2 or 3 years, we have to see when other conferences take place, not to have a conflict. As you can see, there is a very strong support team for the scientific aspects, the organizational aspects. So please revert to us if you feel that your institution, your country, maybe sometimes you have opportunities when a member state of the European Union takes the presidency of the Council to organize international conference. So please think about it so that we have the opportunity to meet again and to enjoy several days of very fruitful discussion on marine data. Thank you.
Very shortly, just to say that our presentation and recordings will be published on the IMDIS website and IOD YouTube channel in the beginning of June. So in next weeks, we will send an email through the mailing list to inform you all when it's available.
And then I think I said thank you all for coming. It's been nice having you here. Welcome back. So this closes this conference. Goodbye.